We should start. Hello, everyone. Thank you for joining us. First of all, I would like to introduce you Michela Espagnuolo from the Institute for Applied Mathematics and Information Technologies at the Italian National Research Council. Michela is program co-chair of this workshop together with Javier Melero. My name is Carlos Andújar from the Universitat Politécnica de Catalunya in Barcelona, and I would like to welcome you all to the 18th Eurographics workshop on graphics and cultural heritage. As in previous editions, this workshop is a forum to exchange ideas, developments, and applications in this beautiful field that results from the marriage of computer graphics and cultural heritage. As you know, this workshop was intended to be held in the historical and world heritage city of Granada. Due to the hard circumstances that we are all suffering these days, this workshop, as most international conferences, cannot take place as a traditional face-to-face conference. The pandemic, as you know, is very broad and affecting society, economy, culture, and research in a way nobody could foresee. But we have very important reasons to be happy today because despite all the terrible obstacles caused by the pandemic, our research community made a grade, and many authors managed to prepare and submit high quality papers to the workshop, thus giving continuity to a forum that has been running for more than 18 years. So my thanks go to all the authors who have contributed to this workshop. And I know that this is a tradition in all opening sessions, but considering the pandemic and how it is affecting everything, and in particular culture and research, let me especially thank all authors and presenters. I guess some speakers will be giving the presentation at home, perhaps wondering whether the internet connection would be okay. But if there is something essential for a conference, that's your contribution. So thanks again to all authors and panelists. At this point in a physical conference, the audience would clap to thank the authors. In an online platform, we cannot see attendees' faces, so please do not hesitate to use the Discord channels during the conference, for example, to thank the speakers after their presentations, for follow-up discussions, and any other social interaction. Next, I would like to thank Michela and Javier, the program chairs, Karina, the steering committee chair, and all the members of the program committee for their timely work. As many conferences running this year, due to the uncertainty caused by the COVID, we had to move the submission deadlines from the traditional June slot to October, which means reviews had to be completed in a very short time frame. So thanks Michela, Javier, and Karina, and all the members of the program committee and the steering committee. I would also like to thank University of Granada for hosting the event and kindly allowing us to use Zoom webinar, which is not a free service, as the online platform for the workshop. Thanks also to all of you, the attendees, for joining us from all around the world. Good morning, good afternoon, and good evening, depending on whether you are attending this session from. I'm very proud to announce that 180 people registered for the conference. And before giving the floor to Michela, let me say big thanks to Javier Melero for all the hard work in organizing the workshop. Javier took care of all the organization issues during more than 1 year. We thought a face-to-face conference would be plausible. So think about all the arrangements for a physical conference that at the end had to be canceled when moving to an online format. So thank you, Javier, Michela, for all these efforts. If everything runs smoothly during these 2 days, you should thank Javier and Michela, and you might blame me for anything that doesn't run as expected. So I hope that despite all the obstacles and the distance, you will all enjoy this unusual edition of the Eurographics workshop on graphics and cultural heritage, and that we do our bit to continue to make progress on the use of computer graphics and interactive technologies for cultural heritage preservation and dissemination. So thanks. And now, Michela, the floor is yours.
Thanks a lot, Carlos, for the introduction. I also welcome you to this workshop, which really suffered in at least at the beginning from the pandemic situation that we are all facing. So first of all, I would like to thank once again Javier, because actually he is really the cornerstone of the organization this year, and he also relieved a lot of my work in the program, in the project. Concerning now a few words about the scientific program that we are able to offer you today. We received 21 submissions altogether among short and full papers, and the program today is composed of 7 full papers and the same amount of short papers. They have been interleaved in a few sessions that are grouped according to the most homogeneous topic. And beside the program, we were able, and we thank the organizer of this, we were able to organize 2 panels. One organized and will be moderated by Javier himself, and the other by Holly. And the one that Holly proposed, I think, is really important and very timely in this period. It is about the impact that the situation of the COVID caused, especially on the interaction with museums. And given the topic of our conference, what are the tools, the means that our community can provide also to make cultural heritage more resilient in terms of fruition of cultural heritage to the community of people. Beside this, you can see the scientific program has been already published on the website. We will take care about selecting the best papers of this year event as well, with a traditional offer to publish on a journal. The proceedings are already available on the Eurographics digital library repository, so you can also access the content there. And I guess Javier will give you a couple of details more on this. And one thing before opening the presentation, you will see we will have a fantastic invited speaker. I will be honored to introduce him in a few minutes. And one thing that I ask you all, try to help us making the event as lively as possible. Try to ask questions and to help us make the events more live as possible. Okay, so I think this is all from my side. I think Javier has a few more details at the technical side.
Thank you very much, Carlos and Michela, for helping us in developing this workshop. It has been not quite easy, given the circumstances and the uncertainty, because we didn't know firstly if it was able to be run presentially or not, then if there will be enough contributors. So it has been probably the hardest edition in 18 years. But finally, we are here. Thanks to all of you, almost 200 people have been registered in the platform. All of you have received quite detailed email about the technical issues. You may notice that you cannot chat in the Zoom session. This is a Zoom webinar. During the sessions, if you want to formulate any questions to the speaker, you should write it to the questions and answer tool that the platform has. In that case, after the talk, the session chair will ask the speaker the questions among those that you have submitted. So there is no chat. For chatting, to try to emulate the behavior of a regular conference in the corridors and in the parallel rooms, we have created the Discord channel that you can join and then talk to anyone who is in the conference, sending emails, messages, and making appointments, or the usual way of working during a conference, but in this remote and quite uncomfortable way. Apart from that, nothing else to say from me. Thank you very much for the University of Granada, to the university, my university, and also the Spanish chapter of Eurographics that made it possible that those 200 participants had not to pay any fee for participating in the conference, because there were some sponsors that took care of those costs. Apart from that, just enjoy. We have also live streaming in YouTube. So if at any time you are in a computer or you have very low connection to connect via Zoom, you can connect to YouTube, to the channel that I also sent you the link. So you can follow the conference through any mobile phone with the YouTube app. Apart from that, it's 1:15. We will try to be very tight, very strict in the timings for the sessions. We wanted to start at this quite unusual time for Europe conference, so we can allow participants from America, which are now early in the morning, and also from Asia, that now they are late in the evening. So we have the central part of the day for the conference to allow the most people to come. Willing to receive very good feedback from you, from all the conference and the participants. Enjoy Graphics and Cultural Heritage 2020. And now it's time to start the scientific part. And Michela, it's again your turn to introduce Ivan. Thank you, all of you.
Thank you again, Javier. And I have to say, I'm very, very happy to introduce our invited talk. Ivan, I know Ivan Sipiran since a while, actually due to another Eurographics workshop, 3D object retrieval. So this was the context in which we met first. And I'm very pleased to introduce him here. Ivan is now associate professor in the computer science department of the university in Chile, and is one of the leading experts in the field of shape analysis for 3D object retrieval or matching in general. And he has been working a lot also in the past on topics in which 3D shape analysis, 2D or 3D shape analysis touches really key issues and key problems in cultural heritage. And he will give us a survey, a fly through the potential of shape analysis for cultural heritage, which I think is really one of the key topics of the workshop that we are opening today. So Ivan, the floor is yours.
Okay. Thank you very much, Michela, for the introduction, and also thank you very much for the organizers and all this effort to make this workshop possible. I want also to thank to the attendees, and also I really hope that every one of you and your families are okay in this difficult moment. So yeah, now it's time to talk about one of the most exciting part of my research, which is the application, the real application of shape analysis algorithms in the context of cultural heritage application. Basically, the most interesting topic that I was involved in since probably 6 or 7 years ago is the problem of shape completion. You can see in this first slide, basically the problem of shape completion is how to give the capabilities to algorithms for extracting the shape information or knowledge information from shapes, and to use this information for conservative or restoration problems. In this talk, I will talk about the shape analysis and different algorithms that we have proposed in this topic for dealing with the problem of shape completion for restoration. So the problem of shape completion is the problem in which probably you know that one of the main problem in cultural heritage applications is that we have a lot of fragments that has been scanned with a three-dimensional scanner, specific three-dimensional scanner, and then we can reassemble these fragments or artifacts in order to try to reconstruct the objects. The problem with the output of this reassembly is that sometimes we cannot get more information that we had in the original parts, because probably we have missing broken parts, or maybe we can some parts that are deteriorated. So we cannot get more information than the information that we have in the real world. However, maybe we want to make an effort because we want computational tools for giving more information about this object, probably producing some plausible shapes as a product of some reconstruction, or maybe try to reconstruct the original object as it was in the past. So one of the main problems with the completion task is that we don't have the exact information about the original shape, but we can do some assumptions, for example, like geometric assumptions or structural assumptions about the shape, and we can use these assumptions for propose some computational tools for doing the reconstruction. Basically, what we can do here is to extract the information of the shape using shape analysis, and using this information for the final task, which is the completion of the three-dimensional shapes. So I would like to start my talk giving some details about one of the most important concept in mathematics and also in structural analysis, which is the symmetry. Basically, the symmetry is a characteristic of objects that can be found, for example, in biological shapes like the human brain or maybe animals, but also we can see the symmetries, or we can find the symmetries in the engineering design, for example, for engines or in architecture, and also we can find the symmetries in the universe. So it's a concept that is well established in many of the natural and human-made objects and processes. So and also we have aside from Aristotle, for example, in which the order and symmetry can be seen as one of the most beautiful form of expression in the human being. So if we want to use this concept of symmetry, because we can find the symmetry in real objects and also in human-made objects, the idea is to express this concept, this mathematical concept, and try to get information using algorithms for extracting this structural concept, which is symmetry, to help in the process of shape analysis and also in the process of restoration. Basically, the definition of symmetry, the most basic definition of symmetry, is that if I have an object and we have a transformation, the symmetry, the transformation is a symmetry if after applying the transformation in the original object, we can get exactly the same object. Okay, so also note that this transformation is not trivial, because we are not looking for trivial transformation. We are looking for meaningful transformation. So basically, this expression is the definition of the exact definition of a symmetry in mathematics. And also we can see that many of the human-made objects, including cultural heritage objects, exhibit some different kind of symmetry. For example, the bilateral symmetries and the axial symmetries. So basically the problem in the computational side is how can we define a good way of extracting the symmetry of objects, but the problem here is that we don't have the complete object M, because we can have broken parts, or maybe we can have missing parts. So basically the problem here is how to deal with this definition, and also with techniques that can cope with shapes like in this example. Okay, so we don't have all the geometry. We can use this definition, and we need to provide good guarantees for the algorithms to even in these cases to work fine. Okay, so I will introduce 3 techniques that we have worked in the past. Basically, all these techniques are relative to the computation of symmetries from broken objects. And the first technique is the definition of a heat diffusion process. The heat diffusion process is a very well-known theory and set of algorithms in shape analysis, but in this case for reflective symmetry. So basically, if we have a 3-dimensional shape, and this 3-dimensional shape has some missing part, our idea is how to compute a function over the surface. In that case, we need to find this function in order that this function help us to reveal symmetric structures. Okay, but we have two problems in this scenario, because if we go to the heat diffusion process theory, the heat diffusion process theory is basically a global analysis of shapes, and in this case we don't have some parts, so basically we need a more local analysis. So basically we need to reconciliate the symmetry awareness of the algorithms with the robustness and the resilience to missing parts. And this is a technique that we proposed in 2014, and this is basically the core of our research, in which we define a very good function to produce very good candidates for symmetric structures in 3-dimensional shapes. Okay, so just to give an idea about what is the theory behind this problem, if we have a compact manifold M, the process of heat diffusion is governed by this partial differential equation. This partial differential equation gives us an idea about how the distribution of the heat in a point is diffused with respect to the time. So basically the idea here is that if I put a heat source in one point, I want to see how this heat is transferred around the surface with respect to the time. Okay, and this partial differential equation give us an idea about how this process is governed in the surface. Okay, so basically the ratio of change between the distribution of heat is governed by the Laplace-Beltrami operator, which is an intrinsic operator in shapes analysis, and you can see that this process does not take into account the embedding of the shape in the 3-dimensional space, but only is used in the intrinsic space. So it doesn't matter if the object is in the different position in the 3D space. In the 3D space, this equation is basically the same. Okay, so one of the solutions for this equation is the well-known heat kernel. It's basically a function that can be computed using the eigenvalues and eigenvectors of the Laplace-Beltrami operators. And also there is a simplification of this heat kernel, in which we can compute the heat kernel with respect to the same point This means basically what is the interpretation of this formula is that is the heat that is leaving one point after some time. Okay, so it can give some information about what is the structure in the object and what is the structure in the local point. Okay, but one of the problem of this formulation is that this formulation is considering only the low frequencies information of the object. Okay, so if you can note in this formula, we only use a number of eigenvalues and eigenvectors, and these eigenvalues and eigenvectors are more related to the global behavior of the shape and not to the local behavior of the shape. And so we cannot use this original expression for doing symmetric analysis for missing parts, for objects with missing parts. So our idea was to change this formulation to deal with local behavior, and maybe also trying to give some multi-scale behavior to the algorithm. So our formulation was to use a more accumulative expression about the heat. So our idea was to produce a new function in which, in this new function, what we are doing is to accumulating all the heat information from the heat kernel, but with respect to a window time. So basically here we are producing what is the amount of heat with small values of time, and also we are accumulating the heat in different more higher values of time. In this accumulation, what we are doing is just like a heat pooling, right? It's just accumulating all the information about the heat in different scales. And this is interesting because after some mathematics operations, we can get a new formulation for our function. As you can see, this is very similar to the formulation of the original heat kernel, but now what we are obtaining in this formula is a new filter for the eigenvectors, which are the frequencies of the shape. And this new formulation is just a filter that helps to computing a different weight for the eigenvectors and a different weight for the frequencies. But if we can see what is the effect of this filtering, basically the effect of this filtering is that we are using more frequencies in the computational function. You can see here the blue function is the original heat kernels with different values of t of time, and the red functions is our formulation with different values of t. So basically, if we use different values of t, for example, t 0.2, we can see that we are in practice just averaging different frequencies for not only the low frequencies but also the high frequencies. So we are using a mix of different frequencies, which provides multi-scale behavior for our function. Okay, so we also demonstrate formally in the paper that the time t is an upper bound for the response, and this is important because if we change the value of t, we can also know and we can guarantee what is the amount of information that we are using in our formulation. So this is an example of our function. We take one of the cultural heritage object that we worked in the Precious project during this period. Okay, and you can see that the function is basically symmetric, and it doesn't matter that we don't have enough information in this part, but the shape, the function is symmetric. And also we can use this function to produce very good candidates of symmetric correspondences between the points. Okay, this is another example in which we can see the symmetric points in these shapes. Okay, so after completing this step, we can find very good candidates for the bilateral symmetries. And now we need to check if these symmetries are real symmetries or not. So basically, we propose a voting scheme, okay, in which if I have two seats for a bilateral symmetry, what I need to extract is some evidence that this symmetry is real. So basically, we produce a voting scheme in which we take a sample of points in different sides of this bilateral plane, and then we compute some information, for example, the distance to the support of the plane, the normal concordance of points, and also the angle to the bisector plane. So basically, we accumulate evidence that this symmetry is a real symmetry, and then we just select some set of planes that has the highest votes. Okay, so these are some examples. This is for synthetic data. In this part, we wanted to show that our method is resilient to the amount of missing information. So you can see here, it doesn't matter how much information we remove from the shapes, the bilateral symmetry was found very good. And also, we did an experiment in which we propose different resolution objects to trying to get more information. And also, you can see that here, it doesn't matter the resolution of the objects, we can find very good candidates for the bilateral planes. We applied this for cultural heritage objects, and these are objects from the previous project, a project that was funded by the European Commission. And basically, you can see here what is the result of doing our computation of bilateral symmetries in the cultural heritage object. This is a column base in the Trondheim Cathedral in Norway, and this is also an brochure that was also scanned in that cathedral. And you can see that we can propose not only one bilateral symmetries, but we can propose different bilateral symmetries. And also the idea here is we can replicate the information across the symmetry plane to reproduce some missing parts and some missing information from the object. So we can produce a result for the completion. Okay, these are another results. This is a gargoyle object, which is common in computer graphics papers. Okay, and you can see that obviously the idea here was just to produce some missing parts, and also very important here is that all these reconstructions needs to be validated by an expert, but the idea is to produce candidate completions for facilitate the problem of conservation. Okay, this is another example which we can see how our algorithm is able to complete the broken part in this part, and also it's able to complete the geometry in the bottom of the object. Okay, very nice in this technique is that we can produce several candidates. So if we produce several candidates, the expert archaeologists can select one of them, and then we can compute not only the completion of the object, but also we can compute the missing part of the object because we have the original shape. So we can send the missing part to a 3D printer, for example, and we can help in the process of conservation and restoration. These are another examples with the hands-on dataset. Okay, and you can see that our method, even when we have made just a simple assumption, we can get some very good results for completion. Okay, so we also built a system in the previous project in which we take the complete pipeline, even with the reassembly of objects. So we did some, we proposed some methods for reassembly, and then we proposed the method for symmetry-based completion. So basically, the idea was to produce a simple pipeline in which the input is the fragments and the output is the missing parts and the completion of the object. So this is a result of our system in the Precious project. You can visit the web page of the Precious project to get more details about the system and about the techniques that we use in that project. Okay, so there are some limitations. One of the main limitations of this first method is that we need identifiable features. We need some relevant features in the object, and if we have some featureless objects, the problem is that there is no warranty to work in this kind of shapes. For example, this is a shape in which we don't have enough features to get information about the symmetric correspondences. So basically, our algorithm produces a lot of candidates, and maybe some of these candidates are not good for the completion. So there is no way to find continuous symmetries with this kind of approach. Okay, so now our second step was how can we complement this diffusion process in order to find a continuous symmetry, in this case the axial symmetry. And the axial symmetry can be found in many different ancient cultures, because many of the cultural heritage objects were fabricated in a turntable. So basically, they have this axial symmetric or rotational symmetric structure. So basically, now our idea is how can we transform our proposal for diffusion-based function to find the evidence of this kind of continuous symmetry. Okay, so we need to reformulate our method. Basically, this is the definition, the original definition of symmetry. Okay, but in this case, this transformation is a rotation around a generator axis, and the generator axis is basically composed by a vector, a normal vector, and a point. So we can describe any axial symmetry by these two pieces of information, a normal vector and a point. And also we can assume that the symmetry is continuous around all the circle around the generator axis. Okay, so if we have this new transformation, but because we know this transformation, we know this specific transformation, the problem now is how to adapt this formulation for even a more difficult problem, the problem of partial axial symmetry, because the previous approach expects a shape that is completely symmetry. Okay, in this case, we saw that many of the cultural heritage objects are not completely axial symmetric, but are partial axial symmetric. So basically, the idea here in partial axial symmetric is that the complete object is not symmetric, but there are two regions M1 and regions M2, in such a way that the application of the transformation in the first region gives us a result in the second region. So this is the formulation of the partial axial symmetry in our case. So we want to solve this more specific problem, and you can see that this is more difficult than the previous approach, because obviously we don't know the transformation, and also we don't know what are the regions M1 and the regions M2. So we have a complete different scenario. So basically here, the idea was to provide a heat diffusion function. And if we have a heat diffusion function in the object, the idea is that if I have an isometry, the isometry is a transformation that is basically a generalization of the symmetry. If we have isometry, the idea is that this function needs to be preserved even in the presence of this kind of transformation. So if we have this kind of function, I can use this function for the problem of revealing the structure of the shape. So this is our approach. In our approach, we take some shape, we take some samples, point samples in this shape, and then we extract evidence in these shapes about the supporting circles that provides the axial symmetry. And then we can use these supporting circles to extract the axial axis detection and then to provide the completion. Okay, this technique was published in the ICCB workshop in 2017. Okay, so you can go to the paper also to see more details about the technique. So basically, our main observation in this problem is that if I have a function that is invariant to the transformation, to the symmetric transformation, and if I have 2 points that are the correspondence in terms of the rotation transformation, it means that we have the point x and the point y, and I know that the function is invariant to the fm function. I can use this knowledge because if this point corresponds to the same circle around the object, basically we need to constrain that this the feature space in these 2 points is the same. Okay, so yeah, this is a strong formulation for this problem, but we can relax this formulation just by accepting some threshold in this difference. Okay, so basically, if we have points that contains very similar values of the diffusion function, the idea is that these functions can be okay, can be used to find the options. Okay, the symmetric. Okay, so basically the algorithm is to find candidate circles composed of this kind of points. Okay. Okay, so after providing these candidates, we can find a lot of circles, and the idea is to group these circles. So we use 2 different distances. The first distance is about we need to group points, group circles that contains circles which are in the same direction of the 3D space, and the second criterion was to use distance between the normal the centroids of the circles. Okay, so basically here we want to weight the deviation of the circles, taking into account the normals, the direction, and also the position of the circles. So after applying a clustering using these 2 simple distances, what we obtain is this. Okay, because we take the predominant group in the evidence of the circles, and then we use the average axis as the generator axis. So you can see that we can obtain very good results for this kind of shapes, even when the partial symmetry is very strong. For example, in this shape. Okay. So we performed some quantitative experiments. In these quantitative experiments, we provide good evidence that our formulation for the diffusion process, the H function, okay, was the best choice when we have partiality. Okay, so basically this corresponds, for example, this graphics corresponds to the matching accuracy of the function when we have 25% of the object missing, 50% of the object missing, and 75% of the object missing. And you can see that the H function provides very good matching accuracy, even better than the heat kernel signatures and the wave kernel signatures and another non-intrinsic functions. Okay, so now if we want to apply this algorithm for restoration, the idea is to identify the supporting region of the axial symmetry, which is fine to do because now if I have the symmetric generator axis, we can find what are the points that correspond to this axis. So basically we can segment the part that corresponds to this generator axis, and then we can use this part for producing good completion examples for for these shapes. Okay. So there are some lessons learned here. Basically, the symmetry can be recovered from this raw data, but one of the problems that we can encounter here is that we are only using the information of the shape itself, And we are not taking into account that maybe there are collections of objects that is shared some structure, and we can extract this structure from a collection and not only from one object. And if we can make the question that if we can extract a structure from collection of objects, the answer maybe is yes, but with the learning approaches. And one of our recent contribution in this part is that we have started to doing some experiments with the restoration of objects, in which we use the learning approaches for the data-driven problem. So basically, in a recent paper, we proposed a conditional generative adversarial network, in which these conditional adversarial networks receive an incomplete object in form of volumetric representation, and produce a complete object. And the decision of knowing if this to know if this object is a real, complete, and plausible object is to introduce it in a discriminator, in which we can see if the discriminator can be fooled by the generator in a regular GAN methodology. Okay, so basically here the generator is the module that provides the completion of the incomplete object. And the problem here is that we need a very large data set to do this. First, we do some experiment with the ModelNet 4T dataset, which is a large dataset for doing these experiments. And we get some very nice results for doing the completion. But then if we want to apply this for the cultural heritage problems, we needed to collect a set of objects with common structures. Basically, we started with the pottery benchmark, and then we put more models, for example, some models from the ModelNet 4T and ShapeNet dataset, models with the same structure, cup, bottles, and mugs. And then we trained this model with this collected dataset, and we tested with the real scanned objects in one museum in Peru. So these are one of the main results that we got in this experiment. Is just an initial experiment in which we use the very basic volumetric representation, but the nice result here is that we can produce some interesting results in which we can see that this kind of approaches can extract the knowledge about the shape, and also can use the structure of the object for producing completions. Okay. So this final lesson in this approach is that I think that we can use this learning approach, but one of the main problems is the amount of data. In this moment, we don't have enough cultural heritage data for doing a specific training of these kind of problems only with cultural data. In this approaches, we need to use some another shapes, but maybe the problem is we are introducing noise. So we need more data for doing this kind of approaches. And also in cultural heritage data, the interpretability is very important. And I am a believer that the combination of the learning approach plus the geometric priors, in which, for example, maybe we don't need a method that completes the object from scratch, but maybe we can produce symmetric transformations. Maybe we can produce some geometric information about the object and use this geometric information to do the final steps in the completion. And also, I would like to open a discussion about what is the best 3D representation for shape analysis in cultural heritage, because in the shape analysis literature, we have very good algorithms for doing multi-view analysis and for doing point cloud analysis. But I am not sure if this is the best representation for doing this kind of application for cultural heritage. Maybe we need to change the methodology in which we are obtaining the object from a three-dimensional scanner, and this three-dimensional scanner probably is giving us meshes or triangular meshes, but probably the point clouds could be a good option too if we want to use, for example, these kind of approaches. Okay, so I would like to thank to my collaborations and institutions during all this time in which I and my group did this research, and maybe I am I am lacking some people here, but this is just a sample of the collaborators and institutions that helped with this research. And yeah, so I would like to thank to every one of you. I would like to thank to the organizers, and I am open to discuss or to respond to your questions at your availability. So thank you very much for everything.
Thanks a lot, Ivan, and our ploses, remote ploses. Very nice talk and very broad overview. And there is actually already a question from the audience from Michela Mortara, which I'm going to read you. Thank you for the talk. A question as follows: symmetric poses of articulated shapes are considered less interesting in artistic production, even if an object is ideally symmetric, such as, for instance, the human body. Do you plan to tackle the problem of shape completion based on reflective symmetry for non-symmetric poses?
Yes. We are actually trying to make some efforts in this direction, because yeah, it's true that there is no so much shapes and so much samples in which we can find this kind of information. But I think it's interesting because, for example, there are statues in which we can apply these methods, but the problem with the statues is that obviously that they are body shapes, so basically we cannot use the extrinsic reflective planes for this approach. But in this case, we are trying to get some intuition about what is the symmetric, what is the generator information of a non-symmetric or non-isometric objects. So basically, it's not easy because we need to reformulate some things, but we have some initial efforts in this kind of problems. Basically, what we are proposing is just to work with symmetric correspondences, which is the best way to formulate the symmetric information in isometric shapes.
Thank you for the answer. Is there any other question from the audience? Maybe while we wait for an other, I can ask you one thing, which is at a rather generic level, but what is your experience and feeling about the acceptance of methods as those that you described, acceptance for the experts that work actually in archaeology or in the specific domain? What is your feeling? Do they see them as potential helpers or?
Yes, actually, during the Precious project, we had partnered from the Acropolis Museum in Athens, and we had a very good feedback about how these techniques can be really used in the field. Maybe one of the fear of the archaeologists is that the computational tools cannot produce a result that can be used as it is. Basically, what we need to do is to validate the result, and they were happy to see that there are many options in the computational tools for providing some interesting hypotheses about the completions. And this is what actually we did in our system, because what we did in our system is just to output the candidates of the completions, and the archaeologist was in the opinion of accept or not the different completions. And actually we did some experiments doing the 3D printing of some objects, and it was funny that some conservation was performed in very good detail, very good geometric details, and this was very this was one of the things that the archaeologists liked a lot of this approach, that you can produce very fine, detailed completions because you are producing this in a computer, which you can control the error. So basically, this is one of the main things that the archaeologists like it.
No, I agree with you. I mean, we had a similar experience in similar projects. And there is one last question from the audience, Shankara Gangisetti. I hope I pronounce your name well. Nice talk. Thank you, Ivan. My question is, the geometric features like id kernel or other features that you presented, do these features have any difference in understanding the geometric feature importance for representation of rigid and non-rigid 3D objects? I guess it's in terms of efficacy of in the two scenarios.
Yes, and actually all this heat diffusion theory was proposed mainly for isometric problems in which we have non-rigid shapes. But I think the isometry is a generalization of the extrinsic symmetries. So basically, all the knowledge that we have from a non-rigid world, we can apply it in this scenario if we provide a good formulation for the symmetric information. So actually, it's easier to do this in the extrinsic world, because we know exactly what is the transformation, we know exactly what is the error tolerance that we can accept, and it's more easy to abstract the transformation in a mathematical concept. In the non-rigid shape, in the non-rigid world, the problem is that it's not that easy to provide an abstraction of the symmetries, because we provide, maybe we need a map, or we need a big matrix providing correspondences. So I think it's possible. I think we can reconcile these two fields with the use of these formulations. But yeah, it requires a lot more work to do that, because we need to go into the theory to fix some things in this case. Yeah.
Thank you, Ivan. A really very nice talk, and we thank you once again. And
yeah, thank you very much. Thank you very much to you.
Really, thank you. And with this, we end the first session, and I would like to hand over to Chiara, who is going to chair the first session of the technical program today. Chiara, you are here? Okay.
Hello. Hello, everybody. I'm Chiara Eva Catalano from the Institute of Applied Mathematics and Information Technologies of the Italian National Research Council, and I'm very glad to chair the first session of GCH 2020. The session is about 3D data management and visualization, and let's go directly to the first presentation. The paper is semi-automated annotation of repetitive ornaments on 3D painted pottery surfaces by Lengauer, Korman, Karl, Trinkel, Sipiran, Schreck, and Preiner. And Stefan Lengauer is going to present the talk. Thank you.
Thank you very much for the introduction. I hope you can hear and see me. So hello and welcome to my presentation on semi-automated annotation of repetitive ornaments on 3D painted pottery surfaces. My name is Stefan Lengauer and I'm a PhD student at the Institute of Computer Graphics and Knowledge Visualization at Graz University of Technology. And this work was conducted in collaboration with archaeologists from the University of Graz and also Professor Ivan Sipiran, we just listened to from the University of Chile. In this paper, we take a look into how we can support the creation of graphical annotation, also referred to as archaeological drawings of painted pottery surfaces. This process is an important task in archaeology where surface drawings are used for comparison purposes and also for in-depth object analysis. And to date, the annotation is conducted mostly manually, either directly on top of the physical object or also from images, since a domain expert is required in order to distinguish legit painting from various noise sources like fracture lines, signs of erosion, or worn-off surface parts. Unwrapping methods which transform the curved vessel surface into a planar representation have greatly facilitated this task. But still, the manual creation of a detailed annotation, as the one you can see here, takes a domain expert several hours, and it is especially tedious for simplistic repetitive patterns which occur in so-called ornamental bands around the solid of revolution. With our approach, we want to facilitate the drawing of exactly these patterns with an interactive query by example approach in combination with a self-similarity detection. And to this end, we'll leverage the fact that repetitive ornaments do not greatly vary in shape and that several of them occur at the same position along the rotational axis of a vessel. We propose the following workflow, which takes a textured 3D model as input and yields a partially annotated surface as output. So first of all, the surface of the 3D model is transferred into a planar representation with a flattening method like the one presented by Preiner et al. Before the following 4 steps are conducted iteratively until all repetitive surface parts are extracted. Firstly, a user selects one well-preserved ornament primitive from an ornamental band, step 1 here, before self-similarity detection yields a set of candidate regions of similar surface regions. Of course, this could potentially include a number of false positives, which can then subsequently be discarded by the user in step number 3. And then the remaining candidates are written to a blank output image and the corresponding surface parts are erased before the loop restarts at step 1. Previous methods from the cultural heritage domain have been concerned with finding similar geometric patterns on 3D models. There have been, for example, works in the 3D shape retrieval contest submitted by Biasotti et al. As well as Thompson et al. In 2018 and 2020 respectively. In one of our own previous works, which we presented at last year's CGH, we used segmentation in combination with shape matching to discover similarities across different objects. The problem of graphical annotation is slightly different in the sense that we try to find self-similarities of rather simple shapes on the vessel surface. And we found that this segmentation-based approach is limited to depictions or ornaments which are completely surrounded by background and do not have any intersections with other surface paintings. But unfortunately, that's usually not the case for ornament bands. So with that being said, let's look into how we tackle the challenge of self-similarity detection. We employ a sliding window correlation on the flattened surface with the window size specified by the query selection of the user. This provides us with a confidence value for each pixel describing the similarity of the local neighborhood to the query. In this case, a blossom shape in the pink circle selected from the lower part of this flattened surface. We leverage the binary colorization characteristic present in Greek pottery surfaces by correlating the binary surface and query. Apart from being more efficient, this also has the advantage that we can account for locally varying lighting conditions by using an adaptive thresholding method like the one proposed by Savola et al. So this results in a confidence map as the one you can see on the right-hand side, with a value of 1 in the region of the query, values close to 0 in regions which are approximately the binary complementary, and all other regions are somewhere in between, as you can see here. Yeah, even though in this case the other blossom shapes from the ornament band are visible as high confidence peaks, this approach does not account for ornaments which appear in a rotationally transformed manner. Still, this might be the case either due to distortions induced by the flattening step or also due to alternating orientations of the pattern. Consequently, we introduce a degree of rotation invariance by taking the pixel-wise maximum confidence for a set of queries, each of which subjected to a slightly different rotation transformation. Obtaining a set of candidate regions from this sliding window confidence map requires an additional step, a so-called non-maximum suppression, which is basically a thresholding combined with a local maximum search. And here you can see the candidates resulting from our blossom-shaped query as blue circles with an indication of the orientation with respect to the query. And apparently all query occurrences in the ornament band are detected, but there are also very many false positives strewn all over the rest of the surface. This is due to the relative simplicity of the query, which also appears in quite similar fashion in other parts of other ornaments. So in order to discard these false positives, we employ the aforementioned fact that repeating ornaments are arranged in ornamental bands around the rotational axis of the solid of revolution. And since the input of our approach is a 3D model, we have a mapping of the flattened surface to the original model and can compute an so-called isohypsis map, as the one you can see here. And obviously, ornamental bands lie along lines of equal set values. We combine this isohypsal map with the sliding window confidence in order to obtain an isohypsal confidence, describing the probability of an ornament band lying at a specific set offset. To this end, we accumulate the sliding window candidates around a specific set value, weighted by their confidence, resulting in an isohypsal confidence like this. Yeah, where we can clearly observe a high confidence band aligned with the ornamental band of the query. Finally, we obtained a refined confidence map by an element-wise multiplication of the sliding window confidence with the isohypsal confidence. And if we now apply the non-maximal suppression to this combined confidence, we can observe that all the false positives are no longer part of the candidate set. Yeah, and this about sums up the retrieval part of our proposed workflow. Since we're still in the early phase of development, we haven't yet conducted a thorough evaluation of the complete workflow. Nevertheless, we have tested the self-similarity detection for different queries and also different pottery artifacts from different ancient cultures. The object you have seen on the previous slides is a so-called Attic black-figured amphora from ancient Greece, currently apparently from the Kunsthistorisches Museum Wien. And here you can see the result of the first query of the blossom shape with whom we've worked so far. Additional repetitive ornaments on the same surface include this zigzag pattern at the bottom of the surface, as well as this quite simple rod shape. But there are also more complex ornaments like this flower on the neck of the vessel, or these on the bulge of the vessel. Yeah, this last example also shows the limitations of our system's capabilities. For the fourth occurrence of this query shape on the left end of the surface is not recognized since it's simply too eroded. Yeah, even though our approach is tailored to surface paintings exhibiting binary colorization, as it is the case with Greek pottery, we also experimented a bit with ancient Peruvian pottery. For example, here you can see two pre-Columbian pots from the Josefina Ramos de Cor Museum in Lima, with the 3D models on the left-hand side and the flattened surfaces on the right. On parts of the flattened surfaces are superimposed the sliding window, isohypsal, and combined confidences for the query depicted in the respective pink circles. Well, our method works quite well for the first part, where all of the query ornaments are detected. It obviously reaches its limits for the second object, where we can see a success rate of about 50% and yeah, also some false positives. Still, we can observe that the different ornamental bands are clearly visible in the isohypsal confidence maps. And the reason why the latter object doesn't work so well is that it simply cannot be approximated very well with a binary surface, since it has different colors. And this brings us to our limitations and future work. Yeah, the matching via the correlation of binary surface struggles with large and faceted queries. But good news is this part can be readily adapted without changing the rest of the workflow. So to this end, we want to look into more advanced matching algorithms for the sliding window confidence, which can also cope with more complex ornaments exhibiting non-rigid or scale transformations. Also, after finishing our implementations, we want to subject the whole of our proposed workflow to a rigorous usability testing and determine its effectiveness and also efficiency for real-world application. And finally, we don't want to constrain our recognition and extraction to simplistic shapes in ornament bands, but also support more sophisticated shapes which are arranged in other repetitive patterns. So to sum it up, we present a tool supporting the creation of archaeological drawings of surface paintings. Our first evaluations of the retrieval part show that the majority of occurrences of ornaments can be recognized, while disputable or incomplete sections still require the expertise of a domain researcher. And the automatic annotation of complex scene depictions or even the whole vessel surface remains an ongoing research objective. And with that, I want to conclude my talk and thank you very much for your attention, and questions are of course welcome.
Thank you, Stefan, for your presentation. Please, in the audience, ask for questions for Stefan. Meanwhile, I will start with a question for you. You mentioned false positives. What about missing pieces? So when you miss, your algorithm is not able to detect an ornament, how are you going to deal with it in a pipeline of automatic or semi-automatic drawing approach?
Yeah, well, basically the idea is to do not support it with our workflow at all, but to rather follow a greedy approach with a workflow which is able to detect the majority of ornaments, and yeah, parts which are not detected remain up to the user to add to the surface drawing, because it's just a support for a surface drawing and not yielding a finished product, so to say.
Okay, I have a few questions from the audience. Silvia Biasotti asks, I'm reading with you, complex shapes seem to be challenging for surface flattening. Are you planning to consider multi-patch surface parameterization?
We haven't considered it yet, but it might be part of future work. It's certainly an intriguing idea.
Okay. Daniel Cornell says, very nice work. Can the matching also consider patterns from other pottery? For example, look up in a database for classification of known object styles?
Certainly, yeah. I mean, it's basically not restricted to the vessel surface itself, but the same approach could also be used for retrieval across different objects, as we did to some extent with our previous work, but not for ornaments. And this might also be some interesting, bullet for future work, so to say, yeah.
Okay, so that's it. Thank you very much, Stefan, for your nice presentation. Thanks from the audience. And let's pass to the second talk. The second talk is about interaction with 3D models on virtual archaeological sites by Ortega, Garcia Fernandez, Lopez e Calzado. Lydia Ortega is presenting. Lydia, you should share the audio and the video possibly.
Something happened with the video?
Yes, okay.
I'm trying to do it again, so. Are you listening to me?
Yes, perfectly.
And you can watch also the presentation?
Perfect.
Okay, sorry. Well, thank you for your presentation. This is, I was saying that this is a joint work with some colleagues from the University of Jaén, Ángel Luis, José Luis, and Alberto. And in this work, we present a prototype system for assessing to the information of an archaeological site. In fact, to the information that is stored in a database, and doing this through the 3D dimensional representation of this site. So the main idea then is to simulate the way in which an archaeologist visits the physical archaeological site by watching, by interacting with these artifacts. So we work on the idea of to change the sentence that excavation is destruction by excavation is digital reconstruction. In such a way, when an item is extracted from the site, we lose a lot of information. We lose the spatial relationship of this item with the environment and also with the rest of the surroundings artifacts. So it could be sometimes crucial to know which are near and in the way each of these items is a position, which is the position of these items. Any way to understand better the real history. So we are going to add some topological relationship in our database. The system in which we have been implementing is, you can see here the architecture is a client server architecture in which we have in the server side the database implementing in PostGIS, and the client is any device, any computer with Unity. Unity is a well-known engine for video games. So, but it allows us to see 3D models and also interact with them, and also interact with the database that is in the server side through the REST API protocol. So we are going to add some topological information in our database. In such a way, if two finds are close in the site, maybe they could have been related in such a way. So this premise is not really true always, but at least give the archaeologists with an automatic tool to relate pieces, or what is the same, to discard a lot of different pairs that are not related at all. So we integrated in this information in the database, and we are going to do it in PostGIS, okay, using the dimensionally extended 9 intersection model that is implemented in PostGIS. The problem is that we have 3-dimensional objects. This works only for 2 dimensions. So we can use the 25-dimension model, but we prefer to use the one that is implemented. So we have implemented this algorithm in which all these 3-dimensional objects are stored, normally from the same layer, okay? We also give a distance in which we consider that they could be related. This distance is inserted in the algorithm. The first step is to project all these 3-dimensional models in the orthogonal planes, okay? In order to be able to use the IAM matrix. First, sometimes we have to make unions because we have several pieces. So finally, we have only one projection of each item. Later, we create an influence buffer at half of the distance. In each of these planes, we compute intersections in such a way that we have pairs of objects that have been intersecting in the three different planes. Okay. Finally, we have these pairs of related objects, and finally make the specific relation of the ones that we have selected. So, as I mentioned before, the way of accessing to this information is through the graphical interface. We have 3 different levels of details: areas, volumes, layers, and finally the 3D models inside these layers. We are going to see in the next video how we can freely navigate and find these topological relationships. Well, the video is, well, you can see this is made in Unity. We have real information from Castulo. Castulo is an archaeological site in Jaén, in the south of Spain. We have remains from different civilizations like Iberians, Romans, Muslims. Here we can see a view from the DAM from the terrain with the different areas of interest in Castulo. And I'm going to show you different ways of accessing to this information in the database. It's normally through this graphical interface. We can click anywhere and we get the information from this database, okay? So the way to access to these areas, well, we can select which is the ID, by the ID, it's the normal way, but sometimes each area has a specific name, okay? So we can use the name to get to the information. And this is the way we can access to the different layers, buildings, etc. After that, we can select any of these areas. Okay. Inside an area, we can find different biomes, and each biome can be divided into different layers. This information was obtained for Castulo, but we have a lot of problems with this original information. There was a lot of inaccuracy in them, but well, this is a real representation. But now we have problems with the acquisition of data. In this last month, we had to imagine the artifact that could be inside any of these layers. Well, we have been watching the way of accessing to this database. Now we focus on a volume with 3 different layers. You can see the information here again. And later, we select with a click to one of these layers, okay? This information, as I said before, is inserted by hand, well, with no original remains, because we had problem to access to the museum in the last month. Finally, in the last level of detail, we can enter to the layer. Here we can see these artifacts with the specific position from which they were found. This is the main, this is one of the main objectives of this project. And we can see which one could be related at a given distance. We have computed this relationship between this each item with the rest of the surroundings. We can get information about the distance, for instance. Again, only when I click, we are getting the information from the database that it is stored in the client side. So basically, this is the results. At the moment, there are a lot of work in progress. We have seen a conclusion that we can access to this information through a three-dimensional interface by navigating and simply by clicking on the objects. But computer work, we have to make the interesting or direct way to insert this information in the database. We have inserted transformation metrics for each element, but now this by inserting this information by hand. So this is one of the things for the future work, and another is to give information about the timeline of this exploration of this archaeological site. So that's all. I think I'm almost in time.
Thank you, Lydia, for your presentation. While we wait for questions from the audience, I will start with a question. You mentioned in the end that the topological relationship that you compute, you do it manually pre-processing, I guess. So my question is, what about, considering that an archaeological site is a living entity, excavations do last years, how do you plan to optimize your software, your tool, such that the new information is integrated in the system in a better way?
Well, in fact, the topological relationships are computed automatically by PostGIS. The problem is how to insert the representation, the three-dimensional representation of an object that has been extracted. So this is the work in progress, in fact, because you only have at the moment a photograph. So from a photograph, it's difficult sometimes to know which is the exact position of the artifact. Okay, so it's the work we think is focused now in this process of acquisition. I think we can use different acquisition methods, but we don't know exactly which is better for that, because photograph, we have been testing with photographs, trying to deline which are the borders, frontiers. It is very difficult because sometimes the ceramic item has exactly the same color as the surrounding, so it's quite difficult. So we have to investigate the way to make this acquisition and insert it automatically in the database. This is, in fact, the work in progress, and with respect to the environment we have, and also the way to interact, to insert this information automatically. But it's true that we have to make make the three-dimensional objects from the site. Okay, so it has been extracted. So before extract, this artifact must be recorded in such a way to get the original position.
Okay. We have another question from the audience. Panayotis Karalomous, sorry for the pronunciation. Before the projection of the artifact, do you do any analysis of the shape to find optimal projection planes? If not, are you considering this?
I think it's more or less the same as I said before. I don't mind the way in which you have the original piece once it's extracted, you can make the 3D models whenever you want. We have been trying to do with a scan, 3D scan, hand scan is no problem. With photogrammetric methods, we need more. That's the problem. We need a lot of photographs to get the 3D models, okay? So the reason why we don't have the originals from the museum. But once there, how to represent into the database the object as the original way is something that is not easy, because maybe when a photograph may be enough or maybe not. So this is the problem. The key idea is to get the information and extract exactly the position from the original site before being extracted. So this is this is the challenge, I think, to this work. And we have not solved at the moment, but I think it would be a very interesting, because we have the second part of the system, but we need to work about the way to get this information to feed the database, in fact.
Yes. Okay, Lydia, there are no questions for you, more questions. There is a channel for the after session discussion on this card. So please consider this. There is another question, just a quick question. This capture position, how about orientation? Dave Martin, is still related to what you have just said.
Exactly, it's orientation. Maybe with techniques like leader, don't know, maybe, but we want to use more cheap technology. Cheap technology, because you know how archaeological site works. It's very quickly. There are a lot of people around, so there is something that you could do while they are working. So in Castello, we could see the moment in which there are pieces of ceramic that they were extracting. You have only few moments to when there are no hands around, no, because you are someone that is not apporting necessarily nothing interesting in the moment. So the position is something that we have done at the moment by hand, no other ways. But the interesting thing is how to capture this position in the site in order to feed the database automatically. It's exactly the same concept, I think. Now we are moving the artifact until decide a position, but this is a randomized position at the moment.
Okay. Lydia, thank you very much for your presentation. Thanks again. And we leave the floor to the third and the last presentation of this session. The paper is Traditional-Based Visualization Methods for Archaeological 3D Data and Evaluation by Bernardes, Madeira, and Martins. Paulo Bernardes will present. Paulo, please show, if you can, the video and also the audio.
Hello, are you listening?
We can hear you,
okay,
but you cannot see you.
Yes, okay. So my name is Paulo Bernardes, and I am okay. My name is Paulo Bernardes, and I'm presenting a paper regarding an evaluation of traditional-based visualization methods for archaeological 3D data. And this presentation is structured like follows. I will start with a brief introduction, introducing the motives and some research goals, and speak about basically 3 visualization methods that I'm presenting here, and the evaluation tasks that we have prepared to test these 3 visualization methods, and draw some conclusions of course at the end. So visualization in archaeology is a very interesting theme that is already started some decades ago. But there are always some remaining questions regarding the visual communication. So actually they are mainly used nowadays to enhance the interpretation of the archaeological data, and also to create graphical objects that improve the quality of the traditional visualization. And these problems are some kind of traversal to the main stages of the archaeological process, such as the analysis, the interpretation, and the dissemination of the archaeological information. But regarding the archaeological survey, there is some things, some drawbacks, and it is interesting to use the current 3D models to work as a kind of 3D photograph that that the archaeologists can use to do the analysis and the interpretation of the archaeological site. However, despite the advances of this computer-supported visualization techniques, there are still some important questions that have to be justify our intention, and these are mainly that the visualization tools, they are not quite customized for archaeological purposes, and also generally they take only advantages of the visual features of the 3D models. And so our approach tries to it started to basically to take in consideration some data analysis issues that were common in the archaeological unit, and the question was, how can visualization concretely help the archaeologists to create some insight into the data. And our approach is to mimic some traditional procedures into visualization methods and apply them to virtual 3D models. So these visualization methods, they follow the visualization pipeline model, and they will take advantage of the notation objects of 3D interaction techniques such as the 3D widgets and the 3D sources, and of course use 3D filters to highlight the information that is searched, that is necessary for the analysis. And these methods, they were implemented using the visualization toolkit. So the first method is the interpretation-free alignments, and generally what happens is that the drawings are made on the field, and we can see it's rather time-consuming process to take these drawings on the field. Although it's it's very accurate and very careful done, but it's very time-consuming. And so we think that using the surfaces of the 3D surfaces that are produced with photogrammetric technology, we can extract the main lines from the important areas that are to be analyzed, and to draw some alignments that can correlate the different objects in the archaeological site. The next method is to use virtual oblique lighting. The lighting technique is very much used in rock art procedures to well, carefully survey the surface of rock to define or to see where the carvings are located. And here again we use the 3D surface to project with virtual oblique lighting to enhance some of the engravings. In this case, it's a date. It's 1709 to locate better where the carvings are and to read also them better. The last method is scalar-based segmentation, which is basically used for geophysics prospection in archaeological environment. The geophysics results are not always very readable for archaeologists, and so the idea is to take the point cloud of the geophysical data and use the scalar values that are associated to each point to produce a volume, and using also contouring techniques to extract the range of data that might have some archaeological interest. This data can be further analyzed. So the evaluation of these methods comprehended two groups. First we had the help of some field archaeologists that helped us to design meaningful tasks, and also we had a group of 4 archaeologists with more than 15 years experience that performed the tasks and also that evaluated the performance of the visualization methods and decided if they were interesting or not for archaeological purposes. The tasks are the interpretation free plan of the site. We have to create a plan that serves as a starting point for the site plan, and we. The third task is the perception enhancement with oblique lighting, where a surface will be analyzed, and we have to, the archaeologists have to locate the different engravings in the rock, and also the scalar-based segmentation of an ERT survey. Well, we will try that the archaeologists can highlight and separate the volumetric representation of archaeological anomalies. So the interpretation-free plan of the site, we used a survey made at the Roman building, a Roman bath building in Braga, and we first applied the edge extraction procedure with the default viewing direction, and the first archaeologist decided that, well, this is, although it is interesting because we can see the alignments of the walls and of the different structures of the site. However, there are some noise in the non-photorealistic rendering that we present, and he decided to superimpose the initial model, the initial 3D model, to understand better what are the structures that have been highlighted in the lines. The second archaeologist, he had another approach. He tried to successively exchange the angle of the viewing direction. He started with a 10 degrees angle and 30 degrees and 60 degrees and 90 degrees. However, he noticed that in some occasion, in some point, some contours have disappeared, and so he decided that this was not so good for the final plan. Regarding the perception enhancement using oblique lighting, the first archaeologists used the lighting cone setup, where the lighting cone was set to 60 degrees, but he was not satisfied with it because only some of the engravings were noticeable, and so he changed it to 90 degrees, where all the engravings were already visible, and it was relatively easy to move around with the lighting source to analyze the entire slope of the rock. The next archaeologist, he decided to use the point light source, where he was also satisfied with the result. But the next archaeologist, he tried to change the light intensity adjustment, and he noticed that when the lighting is only 50%, you can see very little, and the images are only perceptible starting with 75%. So the last example of a visualization method is the scalar rate. The scalar rate segmentation of the ERT survey. First, we had to perform the spatial representation using volume rendering, and also the Delaunay reconstruction of the volume. And well, to highlight the scalars of interest, we have to adjust some opacity values. The scalar of the interest, they were calculated by the geophysics that were working with us. And
Paolo, sorry for interrupting. We are running late. Okay. So can you please synthesize and go to the conclusion, please?
Okay. So what we have concluded is that the proposed tasks were all successfully accomplished, and all of them recognize the importance of the 3D interaction, and the functional goals of every visualization method was also understood, and in fact it increased the perception of the 3D models and the production of new objects of interest. Also, well, this approach answered to the problems that were initially proposed by the archaeologists. Okay, thank you.
Thank you, Paolo. Sorry for interrupting, but we are running late, and we have to stick to the timeline. Are there any question, quick question from the audience? Meanwhile, I will ask just a short question. Do you plan, what's your future plans? Are you going to consider other traditional procedure that you would like as archaeologists from the community to have it in 3D visualization tools?
Yes, yes, we will have another approaches that we are actually analyzing regarding to automatically see the height where the different objects of the site are located, to use a color elevation map, for instance, to correlate the different objects that are on the same level, and see if there is any archaeological interest in analyzing them. Yes.
Okay, thank you. There are no questions now, but there is. I remind you that there is the Discord channel where you can thank directly all the speakers of this session and ask for new questions. And with this, a bit late, I'm just thanks again all the speakers of this session. And there is a little break now before the panel. So thank you very much for the speakers and the attendees. Thank you.
Yes, thank you, Chiara. Instead of 30 minutes or 15 minutes of pause, we will have just 10 minutes, 7 minutes. And at 3 o'clock, you know, fast moving the legs and moving the arms. And in 7 minutes, we will have here one of the panels with very top researchers in computer graphics and cultural heritage. And we will talk about the pandemic and how it has affected. So don't move away. We will not close the session. We will not stop the streaming. Just 5 minutes so you can go and work a little bit and go back to the chair. Thank you, Chiara, again, and thank you all the
Thank you all. Bye.
Bye.
So hello, okay. Okay.
I'm sharing the screen, the background before the session starts. Okay.
Okay, so I need to. The panelists are coming up. Right, and do I need to do something to promote them, or will they appear here? Javier?
I think we are panelists already,
Yes.
isn't it, Holly?
Yes.
Okay, so when
Mark
you turn
it's in the other, but I'm trying to find all the panelists to promote them.
Oh, I see. Thank you.
Panelist. Thank you very much.
So we are live on YouTube?
Yes, we are.
Yes. Okay, so we're just waiting here to get all the panelists into the right mode so that they can participate, and then we'll get underway.
Mark and Carla are not yet in the...
Okay. There's Dan.
Only they both are missing. Carla and Mark. Much. I'm still sending an email. No, they are not connected yet. I've sent again the link to them.
Okay. We'll wait, say 1 more minute and then get started.
Yes.
And I'm sure.
If not, as soon as they join, Carla is already here.
Okay.
And Mark is not yet.
Okay, there's
We lost
Carla.
our Wi-Fi for a few minutes, but I think we're back.
Oh, okay. Well, so I think we'll go ahead and get started then.
Yes.
And okay, we're live then on YouTube. I'd like to welcome you all to this panel on the effects of the pandemic on cultural heritage and cultural heritage research, and on the institutions that we work with. My name is Holly Rushmeyer. I'm a professor at Yale University, but of course I'm at home in Old Saybrook, Connecticut. I haven't been to Yale University since last March. So we have a fair-sized group here, but what we wanted to do is really have a discussion about what's been happening, how people have been, besides compensating, the new ideas that have arisen, the new issues. So we'll have some presentation, but probably not as much as the usual panel. And we really hope that you participate with the Q&A, and I'll be reading those out for the panelists to respond to. I'd like to start by having all the panelists introduce themselves. And I'll just call them by first name so they can say their names properly to you and tell you a little bit about themselves. First, let's start with Alan.
Thank you, Holly. So my name's Alan Chalmers. I'm a professor at the University of Warwick in the UK. I've also been stuck in this chair for the last X days since the 24th of March, which is, I guess, one clear reason what the pandemic's doing to us instead of sitting in sunny Granada drinking a beer. My area of speciality is really on trying to create high fidelity virtual environments for archaeology, mainly looking at multisensory, so visual, audio, smell, feel, and taste. And also we're working on trying to try and preserve some intangible cultural heritage, and particularly have a project at the moment trying to capture Morris dancing, which is a key sort of cultural heritage of England. So that's me. Thank you.
Thank you. Karina.
Yes, thank you, Holly. My name is Karina Rodriguez Echavarria, and I'm a principal lecturer at the University of Brighton. My area of interest is the digitization of heritage, whether intangible or tangible, and digital collections, as well as enhancing how people access cultural content. So we have been doing some work during the pandemic to understand what has been the offerings for audiences around the world and how museums have tried to adapt and respond to the pandemic itself. Thank you.
And Mirsini?
Hello, my name is Mirsini Samaroudi. I'm a PhD candidate at the University of Brighton, currently finishing my PhD, and I work also as a research fellow. My research is about digitally fabricated or 3D printed replicas of museum artifacts and how different audiences engage with these objects and what are the requirements and the outcome of such experience in the heritage context. And for this particular panel, we are here to present and discuss about a recent piece of research that was about the impact of the COVID pandemic onto the digital offerings of museums in the UK and the USA.
Thank you. Carla.
Hi, I'm Carla Schroer, and I'm a co-founder and director at Cultural Heritage Imaging. We're a small nonprofit based in San Francisco where it's 6 o'clock in the morning and still waking up. But our focus is on computational photography-based imaging for cultural heritage. So photogrammetry, reflectance transformation imaging, some spectral imaging. And we have a big focus on training other people how to apply these technologies in a scientific and archival way.
And since I see you there, Mark.
Thanks, Holly. I'm Mark Mudge, and I work with Carla. And a lot of what we do at Cultural Heritage Imaging is, of course, training. And we've been fortunate enough to be training some people from Native American backgrounds. And I also represented the US State Department in Nigeria last year doing trainings with museum people in Nigeria. We also spend a lot of our time and grant money working on what we call the digital lab notebook that allows people to adhere to FAIR principles, that is recording process history. And that should be out in a couple of months right now. So we do those things and more.
Oops, you dropped out there, but Thank you. Mateusz.
Hello, my name is Mateusz Domańko. I'm a research and development engineer at Fraunhofer Institute for Computer Graphics in Darmstadt in Germany. I'm mostly involved in research in 3D digitization technologies and applications in cultural heritage. Today I will share with you some of our experiences with different museums and cultural heritage institutions where we supported their 3D digitization strategies. Either we helped them creating completely autonomous scanning workflow so that, for example, curators or preservators can digitize their collections on their own, or we supported them with digitizing of very complex objects, very challenging objects. So together we try to push the limits of what is possible to digitize in 3D. Thank you.
Thank you. Dale.
Thank you, Holly. I'm Dale Cronkright. I'm head of conservation at the Georgia O'Keeffe Museum in Santa Fe, New Mexico. The Georgia O'Keeffe Museum is a museum dedicated to a single 20th century artist, American artist, Georgia O'Keeffe, who did paintings, sculpture, and photography, and is considered to be sort of the mother, if you will, of American modernism, American modern art. We have a museum in Santa Fe, New Mexico, which is small, about 10 galleries with an associated research center, which is where the conservation studio is. And we also open and manage O'Keeffe's 2 historic adobe homes. First one in the village of Abiquiu, which is about 15 miles north of Santa Fe, and her second home in the Ghost Ranch Canyon, about 15 miles north of that. So 2 historic homes furnished, and then formal galleries in Santa Fe. Thanks.
Thank you. And Enrico.
Hello, thanks for inviting me to this panel. I'm Enrico Gobbetti. I'm the director of visual and data intensive computing at CRS4, a research center in Italy. We are active in computer science. My group is focusing on basically all the aspects from visual computing to big data stuff. In the cultural heritage domain, we focus on many things, mainly developing software and doing research, from the acquisition part to the geometry processing part, up to application related to visualization of data and exploration of data. And we also have installation in museums.
Thank you. It's just wonderful to see everybody. I realize I mainly read your papers and write emails to you all, and in my head you all have American accents. It's funny to hear you speak differently. Anyhow, so this is a good experience. To get things started out, Mercini mentioned this, that she and Karina have already published some work on experience of heritage institutions, at least in the early phase of the pandemic. And to expose some of the issues, I'd like to turn it over to them to present a little bit about that work.
Right. So I will share my screen. So I hope that you can see it properly.
Looks good.
All right. So my name is Mercini Samaroudi. I come from the University of Brighton, and I'm here with Karina Rodriguez to present the research that has been already published. Actually, it is a paper that you can find at the Museum Management and Curatorship Journal. And it is entitled Heritage in Lockdown, Digital Provision of Memory Institutions in the UK and USA of America during the COVID-19 pandemic. So to start with the aims of the research, what we wanted to do was to investigate how heritage institutions have adapted their digital offerings during the first, let's say, strict lockdown period, because we are already experiencing a second lockdown. to respond to the new reality and serve communities' needs by identifying what are the types of digital offerings that were highlighted in museum websites during that period. What were the types of audiences that were prioritized with special focus on provision for vulnerable people, because these are identified amongst the people who need most support, especially during these difficult times. What is the type of content that was, let's say, highlighted and promoted, as well as monetization efforts, because we already know that the sector is suffering from a very severe financial crisis due to the museum closures and cancellation of programs. So we had a sample of 83 institutions from the UK and the USA that we surveyed during from April to July 2020. We performed a quantitative analysis of data, and we also have some qualitative insights. In total, we had 922 offerings in our survey. And to start the discussion, we looked at guidance from heritage associations and bodies. And the reason was to find out what is the context of and the purpose of this research in the beginning, and see whether there are any priorities set by this organization and guidance to help the organization survive through this difficult period. So we looked at the American Alliance of Museums, ICOM, Museum Association, also UNESCO has staff, a European Network of Museums. And we found out that they set some priorities, mostly the financial viability of the sector and the museums, security of collections and staff, innovative ways to access audiences, address their needs, develop partnerships, documenting the crisis that has happened in many instances, and advocacy initiatives to protect the sector. There is also some more precise guidance as far as it concerns the offerings for audiences. So some of these include digital copies of artifacts, podcasts, blog posts, live streaming, as well as 3D objects, VR and AR experiences. To start, to help the collection of data and then the analysis, we developed a classification for the offerings. So you can see on the right part of the screen that we had collection offerings, virtual visit learning, communication offerings, and so on. And the audiences classification is something that we have adapted from Jones, which is mostly based on the emotional and social needs of audiences. This is quite new, because up to now we are used to deploying, let's say, demographic schemes or other classifications that are based on audiences' interests. So in this instance, we wanted to see what are the needs that have emerged from the crisis and how can institutions satisfy those needs. So some of the results of this research demonstrate that mostly communication and collection related offerings were the ones that were provided to people, to audiences online. And on the right part of the screen, you will see the subtype, the subtypes that were mostly offered. These are guided exploration in collections, communication efforts, communication about the COVID crisis, collection resources. Mostly communication, let's say, offerings were the most prevalent ones in both countries. In the US, there were slightly more, and this was obvious even from the face of the collection of data, whereas the UK in some instances follows a more traditional, let's say, approach. And the reason that we have highlighted here virtual visit, gallery tour, and 3D collection is that it is of interest to the graphics community as well to see that even though these were prioritized by the associations and governments and bodies in the heritage sector, these have a very low percentage in the total analysis of offerings. In here, we have findings that analyze the offerings per audience needs. So we have the left part, which is the audiences with educational needs, such as parents doing homeschooling, teachers seeking for material online, learners. These are mostly the traditional, let's say, audiences of heritage institutions. In the middle, we have stakeholders, so these who were already involved in museums and institutions and want to see how they can help or how they can support institutions within this difficult period. And on the right hand, we have people with emotional needs, so maybe people self-isolating, feeling stress, anxiety, and experience anxiety, people who may be grieving, and so on. The next slide summarizes somehow these findings. So we will see that learners, teachers are the audiences that these offerings targeted the most. And then we have, let's say, traditional other stakeholders who were involved, but we have new audiences that emerge. So bored people, people experiencing anxiety and stress also appear in the analysis of our data. And art museums, historic places or houses, and art and history museums are the ones that offered, let's say, the most to their audiences. The next slide presents our findings with respect to the types of content per type of institution. So we will see that, again, guided exploration, COVID communication, collection-related resources. So all of these that belong, let's say, to the communication as well as to the collections types of offerings are the most obvious ones. Whereas gallery tours or 3D collections, which again are of interest to the graphics community, but were somehow prioritized in terms of allowing people to access heritage resources in alternative ways. And especially, this is very important, especially nowadays that we don't have physical access to exhibition spaces, we see that they are very weak. Some of the commercial efforts that are noteworthy, because we see that many institutions made an effort to find, let's say, new financial streams, come from these museums. There are other, of course, in our paper, but we could mention these as examples. So you will see at the right bottom of the screen an example from the Birmingham Museum, where they actually offered recipe boxes, so people could order them. They would they could buy them, and they would have in a couple of days a recipe box at home with ingredients and guidance in order to cook a recipe. And then we have on the top left part of the screen an example from the Statue of Liberty Ellis Island Foundation. So they launched an initiative that was about genealogy services. So the curators would actually perform, let's say, their search in the archives and provide this information to interested, let's say, audiences, and people would have to pay for this. And on the top right part of the screen, we have some objects that are on sale at the Fitzwilliam Museum in the UK. And these are cards with art figures wearing masks. And in order to conclude, based on our findings, we would say that digital provision aimed at satisfying, let's say, the needs of already existing audiences mostly. There is evidence of increased visits to museum websites during the pandemic and the COVID crisis in general. So the organizations have tried to, let's say, expand these initiatives and attract new audiences as well. Communication has been particularly increased in platforms that offer a way of communication, of synchronous communication with audiences as well. So we have seen a lot of content streamed on live platforms, on social media, and so on. There is though future potential for developing virtual visits because this part, let's say, of offerings is very weak, still is very weak. In terms of enhancing the connection between the digitized contents and communication, because during this time that we can't physically access a museum and with the stress and anxiety and isolation that many people experience, it is important to find creative, let's say, ways to connect the digitized collection to communication through activities and discussions and live events. Quite important is to address the societal needs by helping especially vulnerable people, because this provision again has been very weak. Disabled audiences, many women experiencing domestic violence, migrants, children with let's say difficult backgrounds and so on, haven't been catered for as much as they should during this first phase, at least, of the lockdowns. And it is important to find new ways to monetize, let's say, find monetization, let's say, ways through this digital provision, because there is the financial crisis that hits hard the cultural sector, as well as collaborating, finding new ways to develop collaborating strategies between organizations. And also we have confirmed already existing research that highlights the lack of skills and knowledge in the sector, which has been more obvious now because many of the people who were working as freelancers are not being paid anymore in the sector to develop, let's say, products that somehow advance the technological offering of museums. And this is something that has to be further developed in-house. And some of the open questions that remain is how audiences engage with this content, what is the legacy beyond the lockdown period, what are the new priorities that will be set by the sector after this experience, and how the current situation affects research efforts as well. Thank you.
Thank you so much. That's a wonderful summary, and to some extent a bit disappointing. We've been doing all this digitization and so forth. You think, well, this would have been the chance to shine, and your findings do show some weaknesses in our ability to use digital contents, and a failure to sort of account for all the audiences we should be addressing. I do encourage people, I see in the attendees list, I mean, I wish we could see people, but I can see names. It looks like there's a good group out there. So if you have questions or comments, please chime in. I think I wanted to, well, I don't mean to put you on the spot, but Dale, since you are on site in one of these institutions, if you could talk a little bit about somehow you've tried to use digital in keeping things going at your place.
Yeah, the presentation was sort of spot on in terms of our experiences and what we've done as well. For example, we closed down, as most people did, around March the 14th for any on-site visits. So all of our public programming had to be virtual and digital. The museum, the easiest thing for the museum to do was to do public programming like lectures, discussion panels, that sort of thing, around the museum collections, around George O'Keeffe. And actually the attendance on those went way up. So for example, so we're a very small museum, and for our normal lectures on site, we would have about 100 people attend. That was kind of the capacity of the lecture space. Typically now for the online lectures, and the online lectures happen about three times a month, we have 300 to 500 people attending online. So in reality, sort of the exposure of George O'Keeffe and sort of our mission has expanded exponentially. And so the demand for content is huge. The difficulty is that as soon as we closed in March, about 50% of our revenue streams are on-site admission related. Right? So it's admission tickets, it's people buying memberships because they're engaged and excited and they want to support the museum, they love the artwork, they buy postcards, all those kinds of things. That all came to an immediate stop. And the difficulty we're experiencing right now is that, first of all, losing 50% of our revenues for the year was difficult to make up in any possible way. There have been private foundations and philanthropists here in the United States. That's usually the model. It's private foundations rather than government jumping in, who have helped us expand our programming capacity. But we had to dismiss 45% of our staff as a result of those revenue streams coming to a halt. And the difficulty is that as much as we would like to do more with our collection imaging, so we would like to do more with our photogrammetry, we'd like to do more with our RTI. We had just completed a project where we rephotographed all the painting collection, oils, pastels, and watercolors at gigapixel resolution. And that's now all available online. But it takes people to create real dynamic programming. And we lost those people. So we're really just wedged in this situation where as much as we would like to do more, we are running literally on half the staff we had in January and February. And that really has taken a terrible toll. And then sort of getting work done on site, obviously there are new health protocols that really slow us down. So for example, in the conservation studio, by New Mexico health order, every room can only operate with 25% of the people that it could have by legal capacity. So in the conservation studio, that means one person. So I can't do anything that requires more than one person. And that sort of focuses things down. So we're looking now at doing more remote sensing. I think remote sensing for us will become increasingly important. So for example, at the Adobe structure, the historic structures in homes, we're looking at remote moisture meters, remote accelerometers, thermal imaging cameras to keep track of moisture migration through the walls, things that we can monitor essentially remotely from home and keep track of the collection in that way and keep track of the historic houses that way, in addition to our sort of normal temperature and humidity data loggers. And adding more remote information is a way that we're trying to adapt. But I think the real problem for us is, and I would love to hear what other panelists say, the real problem for us is that our experience at our museum is that visitors often make their museum visit a social experience. They're there with families, they're there with friends. They are building experiences and histories and knowledge as a social group, right? It's very seldom is this sort of an individual thing. They're having dialogues. They're asking, what do you think of that? That's a weird painting. You know, what was she thinking when she did that? What are those colors? I mean, those dialogues happen, right, in the galleries. And even in our virtual experiences, and I can show you one if we have time, even in our virtual experiences, those dialogues aren't taking place. It is really hard to have a dialogue during a lecture with 300 people. And I think this is what is keeping us from developing an adequate business model, if you will, for keeping the museum going and expanding services, is that the screen experiences is often an individual experience, and people can't aggregate even in 2s and 3s as families and share those experiences in the way that they would in the gallery, for example, and on site. Let me just share my screen here, and I will. So we did a little over a year ago, we redid the photogrammetry of the Abiquiu Historic House and Studio. And from that, I can show you in a point cloud version a kind of fly through of the historic house. And we've done this online a couple times in describing the house and O'Keeffe's use of the house and studio. And people love it. So this is the kind of thing we could do if we had more people and we had more money. Right, so this is looking at the historic home, essentially from a drone, looking at the roof of the historic home. And what we're going to do is we're going to do a fly through here, just as a video, using the point cloud, the dense point cloud. So you're coming down This is looking at sort of where you first come into the historic home. We're going through the entry gate into the entry patio. On the right is O'Keeffe's studio and bedroom, sort of a separate structure. So we're going to fly into that. The reason we did the photogrammetry, and we do the photogrammetry periodically of the historic homes, is because they are adobe. That is, they are mud brick walls and mud plasters. Everything is hand formed. There are no industrial materials besides the windows. So really understanding the 3D contour of the rooms, the ceilings, the vigas, the walls, even the furnishings is all handmade. It's hand modeled. They are sculptured in essence. So we're now sort of flying into a central courtyard. We're going to go into O'Keeffe's sitting room where she spent a good deal of time. You can sort of see the vigas of the ceiling, the built-in furniture on the side. We'll go out into the garden, come around and look at what's called the roofless room, which is a sort of enclosed but open ceiling patio room. Into the kitchen, so we can see the stove in the background there, the sink, the kitchen table, the pantry. So this is the kind of experience that we would love to do more of in not even in virtual tours, but even in public programming in lectures. And I'll leave it there for the rest of the panel. Thanks.
Oh, thank you so much. Does somebody else want to comment on the activities that were disrupted or stopped, and how you reacted to it? Yeah, Carla.
Yeah, thanks, Dale. That was great, and kind of fun to be back in AbQ. Because we worked with Dale on some of the photogrammetry many years ago. So I just wanted to sort of hang off of what Dale was saying, that we work with a lot of different groups, from major institutions everybody's heard of to small museums, but also indigenous communities. And I think what Dale's saying, that his museum experience is happening even more with particularly these indigenous communities. We've been working with groups in Alaska, for example, and Hawaii, and there's a lot of concern about, well, one, they would like to do more digitization of materials. A lot of their historic materials aren't there anymore. They were collected by others, in some cases more than a century ago. And so travel being shut down is also an issue because they don't have access to material. And one of the groups we're working with, the Aleutian and Pribilof Islands, their people are spread across an island chain, and so not being able to travel even to their own kind of museum is an issue. So I think that, looking forward, figuring out how to put more tools in their hands to digitize their material and make it available to their own communities and elders, in some cases to the rest of the world, but a lot of their goals are really more to support their own communities. I think looking forward, it's in some ways easier to make the case now, having us all having this experience of them needing to do that. But in the short term, a lot of those projects that were either underway or being planned, obviously are kind of shut down and hold.
Yeah, I'd like to just riff on this for a second. We know that it's possible for indigenous communities to take responsibility for documenting their own materials. We've seen examples of this in Alaska with native corporations, and now I believe we're going to be seeing it in the actual clans. But the important thing is what they choose and find important to document is radically different from what I or Carla or Alan or Holly might select, were we to go there and say, look, let's collect some stuff for this community. And I give you an example of Ibadan, Nigeria, where there's a beautiful national museum. And I said to them, look, pick an object and we'll teach you how to RTI it. And so they came back with this ceramic jug about this big with some incised decoration and a hole in the side and a hole in the top of the jug. And I said, why did you pick this when you had all this other stuff? And they said, because in our culture, it's so important that we have music that goes along with everything. And this is a musical instrument, right? Used to call the group together and then to support dancing and singing and other activities. And so, you know, it seems to me, just to wrap this up, that starting a model where we use practical to adopt technologies and ways of giving access to the result of this documentary endeavor on a distributed basis is going to work a lot better than focusing on large institutions. And I think one of the great results of this is that the content which is amassed in the world's knowledge base will be much richer, representing far different sets of values, and we'll all gain the more we distribute these documentary and offering activities.
Thank you. Alan.
Yeah, just to add on to what Dan and Mark and Carlos said, I think the democratization of tools is becoming essential. So we were meant to do a big capture of Morris dancing on the 27th of March, and of course lockdown happened 24th of March, and so we simply haven't been able to do that, and the whole project's been stalled since then. But if our tools were in a state that we could ship them, courier them off to the Morris dancers, they could capture it themselves, and we get the data back, then it would help us tremendously. But at the moment, typically, it's very fiddly. You have to set up a lot of expertise involved. And I think one thing we've learned is that maybe we should make our tools far more easy for the actual practitioners to use, rather than have us come along all the time, because, or them come to us in this case, because it simply can't happen. So I think that is definitely something which is going to change. That people are going to try and develop tools that people can create their own content without having to bring in the specialists or go to the specialists to do that.
Yeah, I don't want to put people too much on the spot, but Mateusz, you sort of are in this this area, and I was thinking of your work partly from the point clouds Dale was showing, and then also being in the business of providing tools. Have you been sort of able to carry on your work during this time, or are you changing any of your work?
I would say that actually we see even growing interest in this in the last 6 months. Museums with which we already worked in the past actually contacted us much more than before. And we thought that, of course, that the answer or the reason is quite obvious, because now they see really the advantages that everything needs to go online and so on, that they have to digitize their collections. And actually we asked for the feedback, and the answer was rather surprising. They said that they are aware for quite some time of the advantages of digitization. They want to go in this direction, and now during the lockdown, they were actually they just had more time, so they had more availability. They had time to actually think about next approach, or to do actually things for what they didn't have time before, because they had to open different exhibitions, they had to work with the visitors, and basically now they just found time. That's why we actually got quite a lot of requests for continuing projects, or actually to upgrade some of the digitization projects. And one of the most active museums in this digital domain of digitization of cultural heritage is, for example, a museum of State Museum in Karlsruhe. And they kind of created, it's kind of interesting, they created a new approach for to engage our audience. So, for example, I don't know if we have maybe 1 minute of time. I can show a short video actually of this new concept.
Yeah, sure. A short video, yeah.
And okay, I will just share my screen.
So in this video, just a second, need to start it. So we supported the state museum in Karlsruhe with the new concept where they wanted to create a complete digital experience for the visitors, where the visitors not only interact with the objects or 3D models, but actually they can digitize the objects on their own. So here in the video, we see this new concept of so-called Expothek, where the visitors can go to the museum and they can select a physical object that they would like to digitize. So together with the preservators or conservators, they actually mount the object on a scanner, on automatic scanner called Kultarm 3D, and they can actually digitize the objects on their own. So in this, actually, they try to kind of engage also young people, to attract young people also to be more involved in, let's say, cultural heritage. And they actually said that it's like quite big interest now, and more people actually visit the museum than, let's say, in the beginning of this year. So the concept looks like this, that they scan the object. They can also explore a little bit different other 3D exhibition. And then, for example, in few days, they get a notification that the object which they digitized is already online. And then they can explore it, for example, in digital museum. So with this, actually, I'll just stop sharing, okay. Yeah, so this was just the idea how to actually, one of the ideas how to bring 3D technologies also closer to the public and how to engage audience into digitization of cultural heritage.
Really interesting. Yeah, I can, and besides in museums, you're wondering what can we do? Can there be lessons for people to do things in their own community? I mean, like, since I can't fly around the world and stuff, I mean, I'm starting to look around my own town, and maybe I should just do some work. And we have, historic graveyards and so forth in my own town, and I should really, this idea of engaging sort of citizen digitization is interesting, and how can we expand that? Karina,
Yes,
you?
I wanted to make a point indeed about this balance between how much effort the community spends on digitization to the effort that is spent in enabling forms of access or different ways of access. And we did notice these issues that, of course, most museums will target audiences that already know the museum, right? So they already look into the museum website and look for these experiences. But what about all those people that don't know, as you mentioned, members perhaps of the community that would never have entered the museum, would never search in that museum website for content? How do we reach those people, and how do we maybe as a community provide different types of access or ways that the museum can quickly provide experiences? I think there was some mention about things of being sociable. So being able to provide a kind of social event, but then nobody can speak to each other and you cannot look at objects of the collection, right? But we have incredibly immersive content. We have incredibly immersive ways to potentially engage different audiences. If we can just think of different modalities to provide access to all the content we have already digitized, because you said something really important, that it was an opportunity to shine. Yet, where is all this content we have been digitizing for the last 15 years, right? Where is it? Why we cannot access it? Why people cannot find it? And why we cannot create more engaging or more immersive or more inclusive experiences with this content? So there is still a lot of work, I think, to do around enabling better access to these digital assets.
Yeah, I think that sort of slides us into the new issues that have arisen. I think people have touched on a couple, sort of the weakness in our research chain, that for years we have focused on capture, and we have these piles of models but what do we do with them? I'm still quite taken with that fly through that Dale showed, which is great use of some captured data. Although on the other hand, it's kind of this dreamy or something. I don't know how to say it, but it's somehow stylized. It's not like visiting there. What can we do to make it more like actually visiting that location, and how can we as groups interact with that? And then the issue of getting more people involved locally in judging what to digitize, and to give them the tools not only to do that, but then to do the things with it, to communicate it or analyze it, or giving them the tools to do something with it. Like I say, I don't want to put people too much on the spot, but we haven't heard from Enrico, and I don't know if you want to say some words, particularly about this balance of focusing on what we're doing virtually versus supporting in-person institutions, or
yes. No, I can only say some things about the past and the future. Okay, in the past you said, and I agree with it, there have been many efforts in digitization. Okay, probably we are not quite there, in the sense that digitizing things, especially for the arts, it's not very simple, but there are technologies that allow to do it more and more quickly, more and more precisely, and so on. There have been also efforts into making annotations. There have been efforts into making distribution into databases that are searchable, findable, and so on. This makes it possible to make virtual experiences right now, and we are talking about the fact that these virtual experiences are not really there. Okay, we can distribute them on the internet and so on. My point, however, is that as computer scientists, we should be proud of our capacity to make things virtual, in the sense that this is what allowed people to work from home. We are using Zoom. It allowed people to have conferences, to teach, to learn, and so on. However, if we talk about museums and cultural heritage and life in general, the physical presence is important. And it's important to put back people in museums, because we were thinking about what Dale mentioned, 50% of loss, 50% of people not working anymore. And also for me, I would like to go there and see things, not to stay at home and enjoy virtual life. Okay, I want to see people. This is strange for me, because I choose computer science because mainly I work better with computers than with people. But in general, when I am on vacation or I want to learn, I would like to go out. Okay, so what we can do as computer scientists, in my opinion, all things that we have done to make things virtual can also be put back in museums. We should think about doing things for when this way of life that we are doing right now, everybody close somewhere, is going to end, because we cannot continue like this. It's very nice. So I would like to say our community, especially people in computer graphics, user interaction, and so on, should also think about how to enrich museums by doing installations, how to augment works of art that are somewhere, and so on, and perhaps how to create links between the virtual collections that people want to see before a visit, to convince people to go and have a visit. This is my things. This is something that needs science and technology, because we want to make things big. We want to make things enjoyable and so on. So it's a matter for computer scientists, but it's also a matter of a way of thinking about life. We shouldn't, I think, in this period, think that we should move everything to virtual. Even though I know how to do it, I mean, it's my job. I do massive model rendering. I can render everything on the internet, but I don't want it. I don't think it's the way of doing it.
Alan, you had.
Thanks. Yeah, so I actually want to ask Dale a question. So you've got your fly through of your visit, your virtual visit, and I guess it's to do with the business model. I mean, would people pay for that? And if not, what level of immersion do you think you need to get to the point where people are willing to pay for the visit? If they, and that as a revenue stream, but they can't go there. They've got a certain level of immersion. Maybe they can multiple people. Maybe it's multi-sensory. So I think that's a key point. If we understand what level of immersion you need, at which people start to pay for the visit, then maybe there's a revenue stream there. Do you have any idea?
Yeah, that's such a great. I mean, for us, I think that is the critical question, because as Enrico is saying, the level of support for the organization, that is financial support and emotional engagement with the organization, is linked to place. It really is linked to being in the place, smelling it, as you say, Alan, sort of smelling it, feeling it, hearing the wind through the trees, getting a sensory sense of that kind of thing. And what we're finding is that even though we have much higher attendance to our online programming 3 times a month, like 3 times the attendance, we're not getting 3 times the memberships, people signing up financially to be members every year. And so we're not hitting that threshold that you're talking about, where people really want to support financially. I recently saw a production by the San Francisco Symphony, and I encourage you all to go to their website and see the San Francisco Symphony's production, online production of what they call Throughline. It's essentially a film, but what's really interesting about the San Francisco Symphony's approach is that it is location dominant. That is, that they are emphasizing the San Francisco Symphony Hall, Davies Hall. They're emphasizing San Francisco and the Bay Area, and they're emphasizing new artists, rappers, hip hop, jazz, all types of music within the Bay Area, and connecting it to the symphony. This approach seems to be very interesting, because after the COVID pandemic begins to slow and people can begin to travel and aggregate, the sense of the importance of place, of having those experiences, is now so reinforced. I watch every production they do. I can't wait to go back, and I support Symphony financially, even though I am hundreds of miles away. And that's because it is such a compelling argument that this place is important. And I think that's where we need to begin to work with designers to emphasize place and community and population and creativity, new creativity occurring in those spaces. I think that's essentially what creates the emotional connection to our places, to our collections. There's got to be an emotional reason to want to help preserve those.
Thank you. And now we're only a few minutes left, and we're finally getting rolling with people wanting to speak. Mirsini?
Sorry, I have to unmute myself.
Okay.
So one last remark, which is related to the significance of communities and place, and the physical and the social aspect of a museum experience, is that not only we have to take into consideration that, well, virtual is not the same. At the same time, we have to overcome financial barriers and knowledge, let's say, barriers in order to create these offerings. But on the other hand, is that we have to take into consideration that there is a digital divide. So there is a gap. International reports demonstrate that people coming from Africa, from parts of Asia, from Latin America, do not have the same access to virtual tools, to online facilities as we have, let's say, in more developed countries financially. On the other hand, there are the communities within developed countries that do not have access to these offerings either. So it is a matter of trying to address those issues as well, in order to try to make it more fair, more accessible to everyone, and deformalize the experience, make it more democratized. There is a current discussion about the movement of Black Lives Matter, of repatriation of cultural heritage, and those topics should come into consideration within the current discussions. Thank you.
Thank you. I want to read a question that came in. It says, congrats for this inspiring panel. There is incredible content that can be created, and as time goes by, it's easier to self-create this stunning content. How can we make these possibilities boost our cultural products, revenues, and sustainability? I think these are things that people are interested in addressing. Carla, you had your hand up.
Well, I think if people are
Mark, sorry,
are building content in a distributed way, I think one of the important things to keep it sustainable and reusable, particularly over time, is that there are tools that make it easy to adhere to the FAIR principles that allow other people to evaluate its quality, reuse it, and of course, when it's reused, that helps perpetuate it over time. So both institutions and distributed content generators need a way to make their material truly useful and not simply entertainment.
If I can just add one thing back to Dale and others, is that I think as a community, we really have to find ways to both not just bring in other people as audiences, but empower people to help tell their own stories and narratives. And I think a lot in our field has been done by the wealthy institutions from wealthy countries, and really rethinking how do we bring in those other voices, because I think that's a critical part of, well, of just being good stewards on the planet, of helping cultural heritage. It shouldn't just always be our point of view.
So we're coming to the end of the time, but I think the panel has accomplished what we had hoped, that in inspiring new thoughts and reinvigorating our research, taking into account the goals and issues that have arisen in this crisis. I want to thank all the panelists for making the time under pressure, under this difficult situation. And I'll just thank you very much, and we'll conclude the panel. Thank you.
Thank you, Holly. Thank you for the organization. Thank you, everybody.
Bye-bye.
Thanks, everybody.
Bye.
It was great.
Thank you. There is one missing author from next session. Inside or Ruggiero, please let us know who will present that paper. Okay. For the second, we are going to start the next session. Inside, okay.
I'm here, Tensai.
Tensai, are you going to present?
Yeah.
Yes, I was waiting for you. Okay, so we are going to start right now the last session of the day. Just to remind you that tomorrow we will start again at 1 o'clock Central European Time, at 1 p.m. And this session is a session of full papers. It will take 20 minutes in total for paper, including questions. And we will be very strict in the timing, okay, dear authors. And we are going to start with the first paper called SciencePS, a benchmark for evaluation of photometric stereo algorithms for cultural heritage applications. This is a paper coming from Italy with Tinsai Dureccia, Rogerius Pintus, Enrico Gobetti, and Giacchetti from Verona and from the CS Sport. And Tinsai, as we thought, is going to share his screen and will be able to start. Perfect. Just press F5.
You see it? Can I?
Yes.
Can I start? Do you hear me? Can I start?
What we cannot is to see you. We can see the screen, but not you.
Yeah, because I don't have good internet connection. Maybe in case if I can present
Okay,
without.
fine. Just press F5 and start your presentation. Thank you.
Okay. So, hello everybody. I'm Tinsai Christos Duleccia. Today I'm going to present our work, which is entitled SciencePS, a benchmark for evaluation of photometric stereo algorithms for cultural heritage application. This is a collaborative work with Ruggero Pintus, Enrico Gobetti, and Andrea Giacchetti. So, photometric stereo is a shape reconstruction technique, actually that relies on a multi-light image collection. It's a set of image captured from a static camera position only by varying the illumination direction. So basically, it's a technique for estimating the surface normals of an object given the constraint or light direction and reflectance properties of the materials. These methods are widely utilized on the cultural heritage application domain. For example, for the 3D shape and reconstruction, and which is actually used fully recover from the dense light and normal maps through spatial integration. These algorithms typically they are evaluated on a few benchmark, not particularly actually representative of the typical cultural heritage application objects. And these benchmarks, they do not allow the evaluation of the variability of the method performance as, for example, the function of material types, camera and the light calibration error and different image pre-processing or image encoding formats. So in this work, we propose a novel benchmark, which we call it SciencePS, to test different photometric stereo methods that is specifically designed to evaluate the variability of algorithms performance in different contexts. For example, changing the material types, introducing the light calibration error, using different image encoding, and so forth. So SciencePS is a collection which is rendered with 77 directional lights, which is also placed in the concentric rings at 9 different elevation angles. And when we render these objects, we use the directional lights and no ambient light is employed. So the camera model is orthographic, and we fix the size of the image to 320 by 320, and we use a 60 bits linearly map. So this data set are composed of two subsets. The first one is the single material, and the second one is the multi-material. The single material is the set where all the items are created using the constant materials, whereas the multi-material sets are the the sets where all the items are textured with captured, spatially varying albedo and subdivided in parts with different roughness. So here, in this case, we created the data set with using three untextured geometric models, which is shown on the picture. And these are actually the 3D models Sketchfab website. The first one is a nearly flat planar object, whereas the second and the third are non-planar objects. For this rendering, we have set, as I said before, the orthographic camera looking at the object surface, and we also remove the ambient light. These data sets are, for this data set, we created 9 collection of images assigning the different uniform materials to different surfaces. So the assigned materials, the idea is simulating the different material behaviors, such as matte, plastic, and metallic behaviors. So the idea is doing this, we can able to do the comparison of the performance of different photometric stereometers. So here is the set of parameters we have used to create the single material data sets. The second type of the data set is the multi-material data set. This data set has been created with two different geometric models. This is also downloaded from the Sketchfab website. The first object is actually the reconstruction of the line of Godeshi star, and the second one is the totem pole. So for these models, what we did is actually we kept the original texture as a diffuse texture in the material setting, and then you use the Voronoi texture node of Blender to define a spatial pattern used to map different roughness values for the material in different patches, actually, which is range from 0.4 to 0.8. Here we can see the Voronoi and the different rendering using different light direction. So once we have created our data sets, we have evaluated different photometric stereo algorithms. Actually, these photometric stereo algorithms mainly fall into two main categories, which is actually the algorithms based on model fitting, and which is listed below, and the algorithms which are based on a neural network, or which is also known as the deep learning based approach. Here, the deep learning approach, we consider different types of photometric stereo method. The first one, for example, we stated here, local or global. Local means when the photometric stereo algorithm or the normal estimation process relies on a specific pixel value, whereas in the case of global, it uses the entire image. The second one is the calibrated or uncalibrated. This is also the first case, where in the case of calibrated, there is the light direction. In the case of uncalibrated, the light direction is unknown. So here are the tested algorithms of which relies on or choose a deep learning approach. Actually, the first two of these deep learning algorithms are state of the art in 2018. The papers presented on ACCV 2018, and the last one is still the algorithm which has the state of the art performance, which is presented on CVPR 2019. So the main reason for this selection of these algorithms are related to the popularity of the chosen method, the fact they exhibit good results in existing benchmark data set, which is diligent, the one and only the known one, and the public availability of the implementation. So here is the different experimental results. The result we have found conducting an experiment utilizing different photometric stereometers. So here, the comparison of the method is based on well-known angular error measure, which is defined as the shown form. So in this experiment, we have evaluated the variability of the different photometric stereometers against the different material type, non-uniform, uniform, or introducing some light calibration error. And also we evaluate the performance using different image encoding format, 860 linear or non-linear. The first result is the result of the experiment we have conducted on a single material data set. Here I have put the three tables which shows the performance of different photometric stereometers on the first table is the result performed on nearly a planar object. The second one is on the cone-uniform tablet, and the third one is on the bas relief object. So here we can see that when the materials are really uniform or planar, the global method for the deep learning approach fails, and as you can see that the accuracy of the global method is low for nearly planar objects, which while the CNNPS method the performs well. And in general, we can see that the convolutional neural network or deep learning based methods are far better than the model fitting techniques. Although it's not that much far from the robust or model fitting based techniques. So here we have the experimental result performed on different types of the data set. Here we can see that almost all the methods perform in a constant way for the matte materials and for the plastic. And but we can see that in the case of subsurface scattering, instead there is a performance deterioration. The performance of all the methods is deteriorated in the same way. To see visually, here we have the error map of the experiment performed on the data set, which is generated using the non-uniform or bas relief object. Here from the error map, we can see how different methods works on the challenging methods as expected in the case of here in the figure A, the least square method actually fail. And the effect of here in this one, the shadow and the interpolation is higher. So this is more evident that the Lambertian methods fail. So the experiment, whereas they performed on non-uniform or multi-material data set, exhibit actually completely different results. Here we can clearly see that the SDPS net or the deep learning, which is the state-of-the-art method, fails. This is actually clearly stated on the original paper. Whereas CNNPS is clearly the best method. Here we can see the performance, while even if the robust fitting methods are not too far from this one. Here, it's interesting. Another interesting point from our experiment is that here you can see that increasing or decreasing the number of light, the accuracy of the, for example, CNN PS, which is performed well on the first case, doesn't change that much, but this method, as you can see, completely fail in the case of only tail light direction. Here you can see on the top. Here actually we use only a single ring lights. So to have more clear picture about the performance, here we have an error map. So looking at the error map, we can see that the error of SDPS net is strongly influenced by the background roughness. And here we can see the background noise. And the CNNPS is clearly the most. Here you can see that from the error map is clearly the most effective technique. And even if the performance of the robust fitting method, for example, of the low rank matrix completion method is more or less closer to the performance of the. So we in our experiment also we have evaluated the effect of light calibration
1 minute.
error. So here we can see that the only method that seems to require the accurate light direction is CCNF, whereas the others perform more or less in a good way. Here we have the experiment on utilizing different imaging codings. Here we can see that the performance doesn't change that much. So actually we can use 8 or 60 bits encoding in this case, but this is not true in the case of real acquisitions. Another effect is the effect of increasing or decreasing the light density or the number of lights. Here we can see that more or less the performance is not that much affected by the number of lights. Actually decreasing from 77 to 28, the performance changes a little bit, but not that much. Only in the case of CNNPS or the CNNPS algorithm, the performance become worse. Actually, this comes from the fact that the CNNPS need the dense sample of the light distribution. Another the effect of shadow here also. Yes. In our experiment we have tried to see the effect of the shadow. Actually until 20% of the shadow, the performance is not that much bad, but while we increase the performance, the performance of the different photometric stereo algorithms grows, the error grows rapidly. So the last experimental result is we have tried to remove the asymmetric light, and we have tried to see the effect of this removal. So here also, except some case, the performance doesn't change that much, despite some of the techniques works. So here is the outcome of our experiment. So what we have found from our experiment is that neural methods are quite promising, providing the results, best results in most of the comparison. And the SPSNet is quite effective for an uniform material. However, it does not work in the case of non-planar or multi-material or non-uniform materials. This is actually stated on the original paper also. The performance of this FCN is not accurate on nearly planar objects and does not work well also on a multi-material. The method based on robust slump-based fitting works sufficiently for the matte and plastic material, but less on the. And in general, what we have discovered is that CNNPS is the most reasonable choice in general. However, this algorithm is more sensitive to the accuracy of the light direction or the estimation of the light direction. And on well-exposed image, it seems that it's not that much important to pass the user 8 or 60 bits encoding with gamma or without gamma correction. So in conclusion, in this work, we propose a benchmark SynthPace for photometric stereo method. Using this, we have evaluated the performance of different algorithms for the cultural heritage application. And we have tried to verify the robustness against different factors, as I stated before. That's it. Thank you.
Thank you very much, Inside. Is there any question from the audience? I cannot see in the question and answer. I have just one short question because synthetic images are very nice and they work very perfectly, but is there any test on these algorithms over real images, and do the results are equivalent to what you have obtained? I mean, are always the CNN, the convolutional neural networks, better than the other algorithms? And I mean, the ranking is the same with real pictures?
Yeah, actually, we didn't evaluate, but from the different literatures, actually, from the current state of the art, the performance of the current of the art is the algorithm which is a CDPS net, or which is based on convolutional lunar network. So on the diligent data set, the state of the art performance is the one which is using the SDPS net, or which is based on deep learning algorithms.
So your results are coherent with the state of the art. Okay, thank you. There are not more questions in this. Thank you, Inside. Now we are going for the next paper. The next paper comes from Barcelona. Carlos Andújar will talk about easy authoring of image-supported short stories for 3D scanned cultural heritage. Carlos, it's your time. Thank you.
Thanks for the introduction. Hello, everyone. So this paper is a joint work with Marco Mino and Antoni Chica. This is actually part of the PhD thesis of Marc, but Marc had minor surgery, so I will be presenting the paper. So this work is about storytelling, in particular visual storytelling for cultural heritage. And we assume that a 3D scan model of some cultural heritage place is available. And our main goal is to allow cultural heritage people, for example, historians and curators, maybe with little experience with computer graphics, to create easily these stories. Okay, so let me start with a quick overview of the proposed approach. So from the point of view of the historian who wants to create some story, we wish the authoring process to be as follows. So first, the historian takes a photo showing the items the story will be about. And then the historian prepares some slides using any presentation software, for example, PowerPoint, and using the photo as background, that's important. And finally, the historian tells the story while pointing, annotating, and outlining on top of the photo. So the output will be a video of the presentation. And this concludes the authoring process from the point of view of the historian. Now at runtime, the video of the presentation will be projected onto the 3D model, and viewers, for example, general public or art students, will be free to navigate through the 3D model while the story plays. So this means that the story will be presented in its surrounding context, thus facilitating the understanding of the story in its own situation, environment, and circumstances. As you know, this reference framework is quite important in cultural heritage. So that was a quick overview. So let's move to the motivation. Storytelling is captivating. Stories encourage active participation, the use of imagination, among many other benefits. And visual storytelling is even more effective. And many studies show that our brains process and retain much more information when this information is delivered visually. So storytelling has applications in many fields beyond education, and cultural heritage and history are two fields where storytelling provides a lot of benefits. Here are some adjectives describing well-known advantages of storytelling for cultural heritage. So considering all these advantages, it's no surprise that many museums and cultural places offer guided tours, although this is not the focus of this work. Instead, we focus on storytelling for virtual cultural heritage. So what's the problem? The problem is that the creation of interactive visual stories often involves extensive efforts that might require substantial 3D modeling, computer animation, and even film actors. Okay, so intangible heritage, for example, stories about crafts and traditions, especially benefit from these interactive stories, but require often a multidisciplinary team involving experts from computer graphics, animation, visual arts, and so on. Unfortunately, this kind of storytelling is limited to a few projects. So our proposed solution is to simplify the authoring process as much as possible. And our goal is to let cultural heritage experts to create at least some visual stories, maybe drafts of visual stories by themselves, with traditional presentation tools, for example, PowerPoint, and with an effort comparable to that of delivering an online lecture. And of course, with this approach, we will not be able to create some stories, for example, those requiring character animation. So we focus on the stories about still cultural heritage objects, for example, mural paintings. We got inspiration from many related works, including visual storytelling for cultural heritage, software designed specifically for 3D users, for example, 3D Hub, ShareUp, and Aioli, and tools for annotation and documentation of 3D models. So let me give you an overview of the system. So remember that we assume a 3D model of the cultural heritage site is available. The authoring process starts when the cultural heritage expert, let's say the historian, takes a photo. The system will automatically register this photo against the 3D model, thus obtaining the camera pose corresponding to the provided photo. This will allow us to, of course, project the resulting video and also to undistort the image that will be projected onto the, the image that will be projected onto the model. The system also computes a gradient image to highlight which image parts are more appropriate to draw on top of. And once the video has been recorded, the system analyzes it to detect regions of interest to guide the user attention. And finally, the audience can navigate through the cultural heritage place and watch the stories while that will be projected onto the 3D model. So we assume a 3D model is available. So let me discuss common approaches for digitizing cultural heritage. So, you know, we've seen that there are two major techniques, photogrammetry and 3D scanners. Photogrammetry is very popular because it just requires a collection of photos. In a typical pipeline, images are processed to detect key points, which are represented with a descriptor. And then images are processed in pairs, and key point descriptors are compared to find correspondences. And these correspondences allow extraction from motion techniques to solve for the 3D position of key points, as well for the camera poses. And once these poses have been estimated, multi-video stereo techniques can recover a dense point cloud that can be converted into a texture polygonal mesh. So the problem with photogrammetric reconstruction is that matches cannot be found in textureless surfaces, as we've seen, and photogrammetry methods are likely to fail to reconstruct, for example, these apps, because most of the walls are just white and thus lack features to establish correspondences. And the second major approach consists in using a 3D scanner. High-end laser scanners capture millions of points per second and have tracking sensors so that they can pre-register on the fly the different scans as you move the scanner from one location to another. So this video shows a point cloud from 29 scans. Here we are inspecting the model from the scan location, so we can just render the panoramic images that are captured by the scanner. So if we move away from the scan locations, then we will be able to see the underlying point cloud. So let's assume somebody in the historian team has created a 3D model. So user-provided photos need to be registered against this 3D model. So let me explain the image to model registration, and here is how we proceed. So in a first step, the system gets the panoramas from the scanner. Actually, these panoramas are already registered with respect to the 3D model. Then we extract 6 cube map images from each panorama. Well, actually 5, because one is showing the tripod of the scanner. And then we run feature detection and matching steps, still using only images from the scanner. Since we know that the images correspond to cube map faces, then we use a simple pinhole camera model with known parameters. And then structure from motion can create a sparse model along with the estimated camera poses. So these blue cubes here at the bottom correspond to the estimated QMAP cameras. So all the previous steps use only images from the scanner, so they are executed only once. New user-provided images will be registered against this initial sparse model. So now assume that the historian provides some new photos. The system will extract features from the photos, find matches with the cube map images, and finally register them against the sparse model. So this image here shows the estimated camera poses for a collection of user-provided photos. We cannot check the accuracy of the registration here. So let's see another example. This is a render of the 3D model with color from the scanner. And here we have the expert provided photo projected onto the model. Okay. So let's move to the gradient image. So as I said, the video containing the story will be projected onto the 3D model. And this projection will be okay for roughly planar regions facing the camera, but will be distorted as we project onto surfaces more tangential to the view direction. So we simply compute the depth map of the model. We extract its gradient and map these gradient values to a color temperature scale, where green means safe parts to draw onto and red means unsafe parts. Okay, so the historian is supposed to take this into account when presenting, to avoid, for example, drawing on top of these parts. So let me quickly review again the authoring part. That now that I have discussed the system part. So first, the historian takes a photo, prepares some slides using, for example, PowerPoint, and the undistorted photo as background. And finally, the historian tells the story while annotating, drawing, or painting on top of the photo. Here you can see some sample frames from the video we recorded for the user study. So once the video is available, we detect the regions of interest automatically. Okay, so we take as input the video frames and compute a 2D location within the frame. So if the videos were supposed to be watched on a conventional video player, this step wouldn't be needed. However, users will be free to navigate through the virtual model and thus might not notice the drawings added on top of some parts of the model, especially when using virtual reality devices. So the system analyzes the video to detect changes and extract regions of interest that will be used to draw the user attention, for example, with a virtual laser pointer. So this analysis is performed on a per frame basis. These are pairs of consecutive frames. We basically analyze the optical flow between these frames, extract regions corresponding to high flow magnitudes, and then take the center of the largest region as the ROI center. Okay, so these are pairs of consecutive frames along with the detected optical flow and the extracted regions. So the last part of the system is color blending. So we have up to 3 color sources for every fragment. The model color that is unlikely to have very high resolution if color comes from the scanner. The user provided photo that can have very high resolution, and the video frames that are typically full HD resolution. So for points outside the camera frustum, our only choice is to use the model color. Okay, so maybe somehow attenuated to highlight the visual scope of the story. For points inside the frustum, we propose linear blending between the photo color, which has many details, and the video color, which includes the drawing and annotations from the historian. And the interpolation parameter T is computed from lambda, and lambda is the mean mapping level corresponding to the fragment. Okay, so if lambda is positive, which corresponds to minification from the point of view of texture sampling, the video frame has enough resolution for this view direction, so we use the video frame. Okay. Otherwise, we gradually blend the photo color in to get higher resolution details. Okay, so here parameter B can be used to prevent the video color from completely disappearing in very close-up views. Okay, so this zoom sequence show first the model color. Okay, not much resolution. Now the photo color, a lot of detail, but of course the annotations and drawings from the video are missing. And now the video color. Okay, so for very close-up views, you miss detail. Because of the resolution and our approach. Okay, so if the content of the video is shown unless you get very close to the surface. So let's move to the results. The test data set was a collection of 3D scans showing Romanesque mural paintings. We conducted a small user study to evaluate our approach. And we tested 3 different presentation methods. So showing the video as in a conventional 2D video player, showing the video in a virtual TV, and showing the video projected onto the 3D surface. Okay, we used within subjects design with all participants testing all conditions. And we ask users to rate each condition for different aspects. Okay, these are actually the 4 ratings we collected for each condition. Okay, so we were asking about fun, comfort, exploration, freedom while listening to the story, and also the overall preference. And here are the results for the different questions for fun, comfort, freedom of exploration, and overall preference. Okay, so we did the statistical analysis and found significant differences between user rates for all these questions except for comfort. So it turns out that users prefer our approach over 2D and a virtual TV. Actually, for the virtual TV condition, most users tended to watch the video from a position where the TV occluded a small portion of the view, and their attitude was mostly passive. Okay, so navigation was reduced to a minimum while the video was playing. Whereas for the projection condition, most users continued to look around while the video was playing and showing general more active role. So this suggests that this condition allows users to have better control of the experience. So to summarize, we have presented a simple to use method for the creation and visualization of short stories The main idea is to use a photo to support a video-based presentation that is going to be projected onto the 3D model, so that the photo provides kind of a local reference framework for the story, whereas the whole 3D model provides its overall context. From the author point of view, for example, the historian, we believe the amount of effort is comparable to that of delivering an online lecture. There are some limitations, though. Our approach works best for frontal views of surfaces with moderate depth changes, for example, mural paintings and low reliefs. Tangential views as well as surfaces with large depth variations are less appropriate, as the video frame will be distorted when projected onto these surfaces. On the other hand, the registration of some images might fail. In our experiments, we could register the majority of images, but with those with little or no overlap with the 3D model, of course, cannot be aligned. And finally, the selected photos should have an aspect ratio similar to that of the video. So there are many avenues for future work. Our highest priority is to test the authoring part of the system with actual art historians. We already got some positive feedback, but further studies are needed to evaluate the true potential applications of this approach, for example, for short online lectures, maybe informal storytelling, or fast prototyping of story units. Although some parts of the method were designed specifically for VR, due to the pandemic, we couldn't conduct the user study on VR headsets. And we also plan to further study different approaches for guiding users, as well as how to link the different stories. We would like to thank many people for their ideas and support. And this concludes my presentation. So I will just let the video play if there are some questions. We are in the museum.
Okay. Thank you very much, Carlos. Dear attendees, we are more than 75 people. We are around 80 people all the time, all the conference attendance. So feel free to ask the questions and answers session. I have one. How fast is the matching between the image and the 3D model? And I ask you in that sense, because this algorithm might be very interesting for augmented reality. I mean, if I want to project or to overlay information with some augmented reality devices, you must align the image against the 3D model. How fast, how much fast are your algorithms?
Well, in the so there are two steps. So we first register the cube map images themselves. So this is kind of a post-process of the 3D scanner model, because it has to be executed only once, and this takes about 10 minutes for 29 scans. Sorry, no, not 29 for, I don't remember how many scans, but kind of 9 scans or something like this. And then we tested, for example, about actually I have the numbers here. So it's about 10 minutes for
I mean, to estimate the camera pose, once the expert sends you the photo, how long does it take to find the camera pose?
Yeah, so for example, for 45 photographs, okay, because we also took a lot of pictures so that we could also texture the whole model besides for the storytelling. So for the 45 photos, about 10 minutes, okay, so it's kind of half a minute per photo, something like this. Okay? Well, these times are not linear, but
so it is not suitable right now to live augmented reality interaction.
No, certainly.
But it might.
at least the software is.
Okay, and there is one question, because Monisha asked, what is your opinion to implement this on 3D statues, on 3D models, real 3D, not flat surfaces, to project over 3D models?
Yeah, well, the problem is that probably you think we should think more about how to manage the distortion that would result. So the once you project the story onto parts with large depth changes, as you move away from the position of the estimated camera pose, you will see large distortions. Okay, so maybe one possibility is to kind of not for the user, but force the user, but kind of suggesting the user to keep as a viewpoint which is closer to the estimated camera pose. Okay, so that these distortions are less apparent. Okay, but of course, one of the advantages of this is the freedom of exploration, especially in a VR system, that you can just look at any direction while listening to the story. Okay, so for status, one should deal with the problem of the distortion if we move away from the camera pose.
Thank you very much, Carlos, for your presentation, and also congratulations to the authors for this magnificent work. And I know how hard it is to handle real 3D models from 3D scan point clouds and so forth. So we will deal later on. Tom Fu is going to present the next paper, which is a very interesting paper about virtual restoration of statues and how to apply anatomy changes over these papers. So Tom, I think that she's around here.
Yes.
Yes. Hello.
Hello.
Hello. So please share your screen and start. You know you have 20 minutes. Okay.
Okay.
Thank you.
So good afternoon, everyone. Thank you for being here. My name is Tong Fu. Today, I will present our research on anatomy changes and virtual restoration of statues. This is joint work with Raphaël Chen and Julie Dean. The cultural heritage is the testimony of the past eras, which need to be conserved and restored. Restoration of archaeological artifacts is an important task for cultural heritage preservation. However, traditional restoration processes are difficult, costly, and sometimes risky for the artifact itself. To avoid this, it's interesting to turn to virtual restoration, which allows testing restoration hypotheses and can be later carried out on the real artifacts. So let's start with some restoration example. The Diana statue is restored in the 18th century, which is an incorporation of 127 ancient fragments from diverse sources. Another Diana statue was restored in 2013. Head and torso date from antiquity and come from different statues. These statues exemplify the restoration practices for incomplete statues. Sometimes antiquities are not incomplete, but just broken into pieces and need to be reassembled. Some research of virtual restoration have been done for reassembling fractured objects. Our goal is different from these works. We focus on complete statues' missing parts by other statues. So we developed a framework for the virtual restoration of the statue given by a point site. And we proposed a point cloud skinning processes by using an articulate model combined with the height field. And our virtual restorations has 3 stages. The target statue is the incomplete statue, which we want to restore. These are candidate statues which we choose to complete the missing part of the target statues. In the first stage, we use the Fakir algorithm to register a sphere mesh model to the target statues and also to candidate statues, so that we could estimate statues' pose and anatomy. In the second stage, we use a skinning method to change the scale and the position of the candidate statue by using the same scale and pose as in the target statue. In this example, the arms of the first statue and the legs of the second statue are deformed to target statue's position. Finally, we completed the missing parts of the target statues by combining the corresponding part of candidate statues. The analysis of the artistic statues shows huge differences in body proportion compared to the real human proportion. Here is an example. So for this reason, some learning-based methods such as SMPL model or landscape models, which were trained on real human data sets and work well for the human scans, cannot be used in our situation. Instead, we rely on the Fakir registration method, which has less constraint to estimate the pose and the anatomy of a statue. Let's move to the stage 1. We provide Fakir with a human body template of 22 bones. Each bone is a truncated cone closed by 2 spherical caps defined by 2 intrinsic parameters, length L and 2 radii R, and by 1 extrinsic parameter theta to define the rotation with respect to its predecessor. Fakir is a kinematic registration process which loops forward and backward through the chains of bones to rotate it and rescale bones successively. One bone is adapted to the point site PK, which is the set of closest points of this bone. PK is updated after each step. For a chain of bones, the algorithm starts by first bone of chain, and the extremity keeps fixed while gradually rotating first bone around the extremity and refining the intrinsic parameters of first bone by minimizing the one bone distance function. Then the algorithm moves to the second bone, again using the one bone distance function. After optimizing bone 1 and bone 2, the algorithm considers them as a pair of bones and adjusts their common joints position and radius, while keeping the 2 other extremities fixed by minimizing the 2 bone distance functions. Then the next pair, bone 2 and bone 3, is considered, and the same steps are repeated until the last bone of the chain. Once the chain of bones has been positioned and scaled over its length, Fakir repeats the process forward and backward to refine bones parameters. This time, we considered only the optimization of 2 bones distance function, except for the chain extremities. After several iterations, Fakir results into a registered model representing the pose and anatomy of the statue. Once we got the registered model, we pass to stage 2. The general idea of the scanning is to attach each point to one or more bones with weights measuring the influence of each bone on it. For example, suppose point P is influenced by bone 1 and bone 2. After rotating bone 2, each bone proposes respectively a position P1 and P2 for point P. The final position of point P after rotation is a weighted combination of the P1 and P2. While general scanning methods work on the mesh, we propose a height field scanning algorithm working for point site. We propose to consider the skin of model as a set of the detail points encoded as a set of height on top of our articulated model, and it will be transferred back on the models after pose or intrinsic parameters change. For each point P, we compute the height value HP and its base point P tilde, which is the orthogonal projection on the bone that P is assigned to. Then we apply the point set scanning on the base point. After the base point position is deformed by skinning for the target pose and anatomy, we left deformed base points to the skin surface by using the initial height value of each point and its direction NP. One of the advantages of the height field skinning is one same base point can correspond to several detail points. This makes it possible to handle layered details. When deforming the base points, we could apply any skinning methods like linear blunt skinnings. In order to overcome, but linear blunt skinning or dual codalnium skinning has their shortcomings. In order to overcome the artifact, similar to Kevin and his colleagues' work, we propose to deal with the pose change in a different way that breaks down the movement into its natural components, a bending rotation and a twisting rotation. The weight of the point is not the same for twisting and bending rotations. We can take an example of the movement of our arms. So the arms moves, there is two movement of our arms. It's a bending and this is the twisting. So the impact of the bending on the base point side should naturally be limited to an area loosely enclosing the rotating sphere joint, while the impact of twisting obviously extends to the length of the bones adjacent to the twisted articulation. This is coherent with the fact that underlying muscles are arranged along the bones and attached to the joints. Let's recall the general skinning formula. First, we define the weight of a point P during a bending rotation. Follow a Gaussian profile of the distance from P to each of the bones that influence it. Epsilon R controls the size of the influence area, so that points in these areas are influenced by bone BK and bone BK plus 1. Let's see the influence of the controlling parameter epsilon R. If epsilon R is large, the convex part behaves well with points sliding from the conic parts of both bones to the joint sphere, while an artifact is created in the concave part. On the contrary, if epsilon R is close to 0, which corresponds to no skinning at all, a hole appears in the convex part, but a self-intersection is created in the concave part. This self-intersection is much more visually satisfying than the thinning artifact observed otherwise. Indeed, only the outer envelope is visible, and when allowing self-intersection, this envelope is similar to the one obtained if a contact area was computed between the two bones. To get the most of the two possibilities, we propose to adapt epsilon R so that it is close to 0 for points in the concave part, and it reaches its larger value for points on the convex parts. In this figure, we show the weight evolution for each point. Points such that epsilon R equals to 0 are shown in white. From yellow to red, the value of epsilon R increases linearly. Here we show a comparison for bending rotation. Geoquaternion fixed the volume collapse of linear blunt skinning near the convexity, but artifacts remain in the concave part, while our skinning method gives a satisfied result visually. Now we will focus on twisting rotation. Let us consider a bone BK plus 1 twisted around its axis by an angle beta, with its predecessor's bone BK kept fixed. Such a rotation impacts the points attached to bone BK and BK plus 1. To handle twisting rotations, we replace the linear combination of bone motions with rotation adapted to the points. More precisely, Each point is rotated around BK axis by an angle that depends on its distance to bone BK. So we got these two formulas for one point P assigned to bone BK, rotating around the axis of BK. And we show the comparisons of the two other skinning methods. The last step of our virtual restoration process is to combine parts belonging to different statues after bringing them to a common pose and anatomy. We change the overall elementary anatomies and pose of the complementary model to match the incomplete statue using our height field skinning process. The position of one point P is computed by this formula. It's necessary to adapt the anatomy of the complementary statues for the reason that the morphology of two statues can be quite dissimilar. Compared to our restoration results in right image, the left image shows a restoration without rescaling step, which the restored leg is much longer than its remain leg. We assume that the selected parts and the statues to complete slightly overlap, which is necessary to blend harmoniously statue parts. In this overlap area, information must be merged. Our idea is to replace the height values of P by a Gaussian weighted average of the height values of neighbor points in up layer. Now we show the Fakir registrations on 4 complete statues. We compare the resulting models after skeleton both changes by skinning with our method and skinning with dual coordinates. Our skinning methods clearly improve the quality near the bone joints, as can be seen in particular in red circles. Our method avoids or at least reduce the dual coordinates artifacts around the bone joints. In this statue, we move the right arm, a hole is opened. This can be solved by an imprinting process in the future. Now we show the restoration of 5 other statues. The Aeschylean Venus is missing arms. Same for this one. The arms we have chosen for the 2 Venus statues are from masculine statues. Although the morphologies are quite different, our restoration merges the 2 parts in a satisfying manner. The choice for arms could be done better by an expert. The old fisherman is missing leg, and here is our restoration result. The wounded Amazon is missing an arm. And the limitation of our methods is that sharp junction lines can be observed sometimes in the multi-layered. This due to the choice of the parameter delta when merge overlap area of target statue and the candidate statue. We make a compromise between a smooth fusion and the preservation of styles of both parts. And this statue has a real complete version, which doesn't correspond to our restoration. However, an art restorer with an expert knowledge of the statue history and artistic context would naturally better choose the complementary statues and control the restoration styles. And here is information on statues we showed. To conclude, we introduced the framework for virtual restoration of human statues. For that purpose, we proposed a point set skinning method to modify the pose of the statue and applied it to virtual restoration by part combination. There is still work to do. We want to investigate it an imprinting process, fulfill the whole resulting from a pose change or scanning occlusion. We would like also to design a combination approach more respectful of the style of the different fragments. Right now, we are still missing a user-friendly interface. It will be simple for users to choose candidate statues and compare different restoration hypotheses. Thank you for your attention. If you have any questions.
Thank you very much, Tom. Very, very interesting work. I have to say that I have wounded Amazon full complete from Mexico, from a city from our region. We found one exactly like the one in New York. So in case you compare, we have the ground truth 3D scanner. If there is any question, please write it to the Q&A button. I have one question. What about other methods? Why are you better than other post-estimation methods? Have you compared with other works in the literature and compared both reconstructions or not? Or is planned to be done in the following months? Compare your method with other post-estimation and reconstruction methods.
Yes, now we didn't compare with other methods for the restoration results. So it will be interesting to compare with other methods. Yes.
Okay. I don't find any question more. I can see probably say very nice works, people, very nice presentation, nice work, people agree. Okay, congratulations for your work and hope to see the advances in the future.
Thank you.
Okay, thank you. Nice work from Carlos also. And now the last presenter is a very well-known person from the community, our friend Marco Calieri, will present the paper from another brick in the wall, improving the assisted semantic cementation of masonry walls, which is quite interesting because now we are addressing the issue of once we have the 3D scanned model, what can we do with them to make them useful for documenting the heritage? So Tom will stop sharing, and now Marco can start sharing the screen.
Okay.
Thank you very much.
Good day, everyone. Last one in the session and last one of the day. So let's get it out quick. So I'm Marco Calieri. This is a joint work between our SAB, which is the Visual Computing Lab, which is part of the National Research Council of Italy. We work a lot on 3D computer graphics, especially dedicated to the cultural heritage, and the Civil Engineering and Architecture Division, that is part of the University of Pisa, and they work on the analysis and diagnostics of monumental building, especially related to the seismic risk. So the problem, masonry annotation. What is it? Is a survey, or better, an interpretation of a survey. So you start from a graphical representation of a wall. In most cases, this is an orthographic image. And then you annotate it, labeling the different elements, so different kind of masonry, large stone, small stone, regular parts, broken parts, and also things like degradation. So annotating the object, you establish a detailed knowledge, a detailed mapped knowledge on this representation. Why all this work? For different reasons. Historical studies, so by establishing the different parts, you can reconstruct the construction sequence and map them past modification. It can be used to management and conservation, so you assess and measure the current state of the object, and you can map the degradation for a different intervention, or you can even do structural analysis. So the type and characteristics of the different masonry elements can be used to numerically compute the stability and the strength of the structure. So it's not just a a study over the characteristic, but just you can go also to numerical properties. What are the problems that we are trying to address in this work? Well, first of all of this work is done manually. So there's a person, there's an expert that go and draw all the polygons, all the annotation over the image. And this is extremely time consuming. And most of the time, this work is done in software that are not especially designed for the task of annotation. And this slows down the process and is sometimes prone to error. And the time is sometimes essential because sometimes you work on a small building and sometimes you work on very large city wall. So this is our test case, which is the city of Pisa, and I have highlighted the city wall. And if you're curious, the tower is just here. And so looking at the work is difficult not to think about deep learning and artificial intelligence, because this task is repetitive and you have a lot of input data, and it's based on the idea of recognizing something on images, which makes it perfect for artificial intelligence, especially CNN and the task of semantic segmentation. However, it could be not really useful if you just bring out a CNN and you apply to the data and then we left everything as it is. What we wanted was to create a workflow, create a sustainable workflow that could exploit the expertise of the people that are already working in the field by assisting the day-to-day annotation, providing some automatic methods to speed up the thing, and let them check the result and check and validate the result of the automatic segmentation. This is based on a human-in-the-loop approach. And how we can do that? Using a specific tool, a tool that is specifically designed around the idea of the human-in-the-loop paradigm, which is TagLab. TagLab is an open source annotation tool that is heavily based on the use of CNN, that is developed by our laboratory, that works on ortho image, supporting also large data set and multi-channel image, and provides different level of work. So it can provide things that help a human to annotate in a faster and more accurate way the input image, or you can also work as an automatic recognizer, an automatic segmentation tool after the CNN has been trained on your specific data, so it learns how to work on your data. And then it provides statistics and a specific tool for multi-temporal comparison and this kind of stuff. So what's our plan? So we have the authors, so all the data that we have to annotate, and we have the expert. If we give the expert the assisted annotation tool, so they are the tool that can help in doing the annotation, the expert can produce the annotated orthographic images. And this can be used then with the TagLab tool for the analysis, like statistics, monitoring over time, whatever. The problem is we don't have few orthos. We have many orthos, many more orthographic images to annotate. And at this point, a completely manual approach does not scale up. So the idea is we use all the data that has been already annotated to train a CNN that then is able to process all these input orthographics into annotated orthographics. However, CNN are not perfect, so this data may not be as good as the manually created one. So what can we do? Well, we can give the expert the TagLab edit tools, so in this way he can go and correct everything was not correctly annotated by the CNN, and this results in well annotated orthos, but also the data coming from these new annotated orthos can be used to retrain the CNN and making it a better CNN. So something that is better at doing the work. So the next time it will be used, probably, possibly, it will have produced better result. And also in this case, all the result can be used with the analysis tool to create statistics, monitoring, and whatever. This is what we call the interactive annotation cycle. And by keeping the expert, the human inside this loop, we are providing a workflow that can be adapted to small cases or larger cases. So the first part of our experiment was the one about the assisted annotation, so helping the expert in their manual work. So the expert is an engineer from the division of civil engineering and architecture that already worked on measuring annotation on this specific data set. The training took just a couple of hours. The TagLab is not so complex to use, and since it has been designed for this specific purpose, all the tools are focused, so it's easier to learn to use it with respect to more complex generic software. The data is 9 orthographic images of the Pisa city walls. These come from photogrammetric survey, so the usual pipeline. You take photos, you process in metashape, and from the resulting 3D model, you generate the orthographic view. The objective was mapping 9 classes of masonry, depicting a different kind of. You can really see also in this example here that a different part of the wall built with a different material or different style. So what we gave to the expert were a set of specialized tools for creating the annotation. One is this one, which is called the 4-click annotation tool. It's based on a CNN, on an agnostic CNN. So this CNN works on every kind of data, which is called the deep extreme cut. So it's a very quick tool. The user has to pick the 4 extremities of the object you want to select, top, bottom, right, and left. And the software automatically creates the annotation. This is very good for closed elements. This is a caper plant, but also put log hole, which are the hole left by the construction. So the scaffolding using the construction left holes in the structure, arches, and other small elements of the wall. The other parts, which are made of large coherent areas, sometimes extending to the image border, so they are unbound areas in some sense. There's another tool that is based on the watershed algorithm that provides a sketch-based selection. So you have sketches, you set the sketch of the specific class that you want to annotate, and you draw things on the image. You draw the parts that you want to annotate with a specific class, or you just use a neutral color to say just ignore this area, and the result is automatically computed by TagLab. Then, of course, it's also possible to manually draw the polygon entirely, and then you can edit what you have obtained with the assisted annotation tool using, again, a very quick and focused editing tool, like the one that is sketch-based to redefine a border, or an automatic border refinement that is based on the graph cut algorithm. Then you have area booleans and all the other tools that you can imagine in a software like this one. So using all these specialized tool for annotation, was the expert able to do his work? Yes. This is an example of a manually annotated orthographic image. You can see that different parts of the wall, different kind of masonry has been correctly annotated and associated to a specific class. These are the log hole that I was saying before, so the remaining of the scaffolding when the wall was constructed, and these are mostly caper plants. So this is a very good result, especially because the process was faster. So on average, to annotate an area that is around more than 200 square meters, it took 40 minutes in TagLab, while it took 90 minutes on Adobe Illustrator. That was the software used before. And the result is more detailed because the annotation, as you can see here, is pixel-wise instead of being composed of many points on a polyline, and with the coherent adjacent contour. So you have a better representation of the whole structure. The output is already compatible with the current workflow that they have, and then you have all the tool for extracting statistics and measurement from the data. And here we start the next step. So it's possible to help the annotator do his work with the assisted tool. Now we want to scale up. We want to see if this data is able to train a CNN to automatically solve the problem. So we started from the 7 annotated maps done by the expert, and we used these to train the CNN. The idea is then to use the CNN to process the remaining orthographic images, and then let the expert correct the prediction and feedback the corrected maps as ground truth to retrain the CNN. This is our loop with the human in the loop. The CNN was training using the TagLab Train Your Network feature, and these are some detail about the CNN. So the architecture is a DeepLab v3+, which is good for semantic segmentation. The preprocessing is quite standard. We scaled everything in order to have the same DPI value. We created the tile, and we normalized the tile. The augmentation is very, very simple because, for example, you don't need rotation because all the images are correctly and coherently oriented. And the training try to exploit the pre-trained weight as much as possible. The data set is class imbalanced because some, if we go back, some classes like this one, you can very well see that are much larger in terms of pixel size, of image space, with respect to things like the put holes. So we use a specific loss function that helps in rebalancing the different classes. And the training time was 9 hours using an RTX 2070. So pretty standard hardware, pretty standard times for this kind of application. So after the network was trained, it was applied to the new orthographic images, and this is the result. This is the input, and this is the annotation. The input, the annotation. So again, you see that the network was able to get very well most of the classes, and even though you can see that some part may appear strange, so these are small things that we will see later. But the CNN was able to work on this new input data, so unseen data not used in training, with very, very good result. So the model reached a very high accuracy and mean intersection of a union. And we evaluated this value by comparing the result with the correction made by the user. So after the automatic annotation, the expert used the TagLab edit tool and was able to correct the incorrectly annotated parts of the image. This took 20 minutes. This is still a very good news because, as reference, when the expert started from scratch in annotating a new image, it took 40 minutes in TagLab, and with Illustrator 90. So being able to just spend 20 minutes to have a perfectly annotated orthographic images is a very good result in terms of time and the and scalability of this process. Conclusion. This is still somehow an initial experiment because we only had 9 orthographic images, so we had some to test the initial step of assisted annotation, and then not much data to really do the cycle of retraining the network. So we plan to expand our data set and annotation times. However, even from this initial experiment, we may say that yes, assisting the expert does work. So it improves very much the scalability of the process, giving specialized annotation tool to the expert. These speed up the manual annotation and produce better results. And it's also possible to go in a fully automatic way. So the data that is created using the annotation with the assisted annotation tool can be used to train a CNN, and the result of the automatic segmentation are very, very good. They still need some tweaking, but again, by using the integrated tools, this can be also quick. More importantly, however, more than the specific result of the CNN or the other tool, the important thing that we believe comes from this work is that we established a workflow. So we try to build the technology inside a human sustainable process. So exploiting the competence and the expertise of the expert, and providing a method of work that is sustainable and scalable with respect to large scale work. Future work, other tool, because the assisted annotation tool work well, but we see that every time you change from one domain to the another, from the corals to the walls to other object, you probably need some specific assisted annotation tool. Multi-channel, we can also try to work using not just the orthographic image, but also the depth map coming from the reconstruction, or using some non-visible, near-visible imaging, like infrared, for example, that will probably help in discriminating better the kind of degradation. And since I spoke about degradation, work on the degradation, so map things like cracks, streak of dust, broken elements. This might be more complex because the degradation happens cross classes. While the classes are very well defined, the masonry classes that we worked on, so large stone, small stone, bricks, are very well defined in terms of texture. Some of the degradation happens across different classes, so you have to separate the degradation from the background. And surely, also in this case, we will have unbalanced classes. And then another promising way is to work stone after stone. So instead of separating the different kind of masonry, segment each stone individually. This is useful for specific structural analysis. I finish it. Thank you for your attention, and I'm available for questions.
Thank you very much, Marco. You can feel the virtual applauses of the people like the other presenters, but this situation is the only that we can imagine. Please attend this. I'm waiting your question, but I have at least one for you. What about convolutional neural networks in 3 dimensions, not over images? I mean, why over? I know why, but I want to hear from you about the usage of the CNN really in the 3D world, because it is a gap still, because we are now starting to use machine learning on images, sometimes parameterized models. What about the 3D space?
It's difficult because, as you know, the data, the input data just explode. In this case, however, if we think about a wall of similar situation, where in this case, the section of the wall were almost flat, so an orthographic image contain enough data. If we think about using also the depth map, we can add 2D.5.
Yeah.
And even if we think about some more complex shapes, so like the apse of a cathedral or things that are extremely curved that you cannot really approximate with a simple flat map. In that case, the recognition should be on a smaller scale. So it's not necessary to get the entire 3D model inside the network at the same time. So also in this case, the work was done in tiles. Was done in tiles. So even on image, you work tile by tile. And so even if you have a 2D.5 or even a 3D representation, for this kind of application, you can have a sliding window over the 3D geometry and only work on that specific part.
And probably using normal maps for detecting the bricks.
Yes. And in that case, you will not have the 3D, but yes, you are transforming the 3D to something that is 2D multi-channel.
Right.
For this kind of application is perfectly fine. It's what we plan to do. So we plan to add depth map, but as depth map. So it will be RGB depth. And this will really help a lot, because from that thing, you can much easier get the cracks, much easier get the gutters between one stone and the other, this kind of stuff.
Okay. Thank you very much, Marco, for adjusting to the time. Thank you all. There is one question I just realized. Carla and Mark says, this is great. We often produce registered orthomosaics and digital elevation models from photogrammetry projects of murals and paintings. Could this tool be extended to support things like wall paintings to identify, for example, cracks or other conservation issues? Yeah.
Possibly. I mean, if there's something that can be annotated in terms of isolating an area and make the network and train the network to recognize those characteristics, possibly yes. So the idea would be to load the data, annotate it, and when you have enough, you can train a CNN to try to recognize this in unseen data.
Okay. So thank you very much, all of you, for attending this day and this session. We close the Cultural Graphics and Cultural Heritage Day 1, and we will meet all together tomorrow at 1 o'clock. Is it, Mickey? Michelle?
Yes, exactly.
Okay.
We hope you enjoyed.
Yes, we have. So let's stop the transmission, the live transmission.